Okay. All right. Good evening, everybody. This is Tech Thursdays, episode 75. We missed last week because I was out of town on business travel, so I thought we could probably do that episode on Friday, but I wasn't. My flight was delayed, so I wasn't able to get into town until Friday evening, which is the reason why there was no Tech Thursdays either on Thursday last week or on Friday. But that being said, I decided we're just going to go ahead and keep rolling. So this is the next episode. There was no episode last week. So if you were relatively new to the channel and you're wondering what's going on, I thought these were Thursday shows. So that was a one-time thing. So anyway, that being said, there's a lot to talk about on this episode. There's a lot of leaks, rumors, RTX 5090. We're going to be talking about the 50 series in general. We have talked about NVIDIA's 50 series before, but I think as we get closer to NVIDIA's announcement, we're going to go in more depth in terms of what to expect, because there's a lot of interesting information with the 50 series. The other thing too is, so the AMD Zen 5 motherboards, the accompanying chipset, so the X870, that is also launching later this month, although I think it's at the very end of this month, which is kind of a weird launch, but MSI had some pretty interesting announcements. We're going to talk about MSI's X870E motherboards, because I think MSI, currently, from what I've seen, MSI and ASUS seem to be the top choices. And then ASRock, as you guys can see on the screen here, these are the ASRock motherboards. So those were also announced earlier this week. And then Gigabyte, I think they did theirs 2 weeks ago now, and ASUS was Gamescom was when ASUS announced theirs. So that was the week before. So now all the X870E motherboards, including, I'm guessing, the flagship motherboards, although MSI did not announce a X870E Ace. However, they did show off the Godlike, which is what we're going to talk about later this stream. We're going to talk about the motherboards. That being said, the only thing that I can see as a differentiating factor, let me see, where is MSI? So MSI, the only thing I'll say about these new motherboards, for those that are curious, what could be the difference here, the only thing that I can see as being something that could be potentially a game changer compared to the previous motherboards, which would be the X670 motherboards, would be DDR5 speeds, and particularly 4 sticks of DDR5. So some of the enhancements to the board design with these X870 parts are typically around DDR5 and VRMs, although there was way too much emphasis on VRMs, which was kind of disappointing that they talked a whole lot about the VRMs, and I'm just sitting there listening to them talk about VRMs, 24 plus 1 plus 1, or 24 stage, or 26 stage, and I'm thinking, none of these CPUs, even the flagship 9950X, doesn't pull that much power. I mean, I don't understand why, they're talking about these insane overbuilt VRMs for these motherboards, especially the Godlike, and I think the Carbon Wi-Fi. But other than that, my major hope for these motherboards is that the DDR5 speeds will be improved, because we saw a little bit of that for Intel, because you guys remember Intel Z690, going from Z690 to Z790 saw a very good improvement with DDR5, particularly 2 sticks of DDR5. Now, 4 sticks of DDR5 on Intel is still pretty terrible. You can't do anywhere, you can't reliably go above 4800 on Intel, and even then that's considered a severe overclock, and that's not supported if you're running 4 sticks of DDR5. So AMD does a little bit better. I mean, AMD, I've been able to do up to 6000, although it requires a lot of trial and error to get it to work. So my main hope is that these X870E motherboards, particularly the flagship boards like the Hero from ASUS and the Godlike from MSI, and I guess maybe the Taichi and the AORUS Master. Hopefully those motherboards improve the ability to run 4 sticks of memory, because there was some talk at the AMD Tech Day thing where they had all the media outlets talking about, or where AMD was like showing off Zen 5 and liquid cooling. But what was weird was they were saying how, and I know Wendell from Level 1 Techs, shout out to Wendell, like he was saying this in his video, that there were some settings in the BIOS for like making it easier to do the memory stuff, like in respect to like 4 sticks of memory, but that doesn't exist on X670. So we're gonna have to wait and see if these new motherboards actually have those enhancements, because that's kind of the thing that I'm hoping that they can do. Because like if you're someone who's interested in building like a super high-end, kind of like almost like an HEDT system, but not quite a workstation, but you don't want to spend money on a Threadripper and a really expensive motherboard because you don't actually need the PCIe lanes, but you do want like the memory density and the compute and all that stuff, as well as the gaming performance. I kind of think that hopefully X870 improves the memory in that regard, but that remains to be seen. How fast do we think we can get 192 to go then? We have no idea, because those motherboards don't exist. What I can tell you is the 9950X. So I am using the 9950X right now. Like that is in this computer that we're streaming on. That was running 192 gigs. I was running 192 gigs for the last like week and a half at 5200, and it was 100% stable. Now, I was thinking of trying to go to 6000 and 5600, similar to what I did earlier this year. So if you guys, I think it was this year. Was it this year? Was it last year? So anyway, I've already shown how to do 6000 on 192 gigs on a older 7950X, and that's on X670E. So it is possible to do 192 gigs in the range of like 48, well, okay, 4800 works for everybody. That's not a problem. Where it becomes problematic is when you want to go above 5200 or 54. Somewhere in the early 5000s, it becomes much more challenging to push beyond that. So without being able to manually tune the bus termination, the most you can hope to do on the current X670E is like 5200, 192 gigs. So what I can tell you guys with the, where is it? I don't know where my, so anyway, with Zen 4, so this is a 7950X3D. With a 7950X3D or a 7950X, you can expect to do around 4800 to 5000 with 192 gigs of memory on X670E. If you're on Zen 5, you can easily do 5200. You can do 192 gigs at 5200. I can confirm that. I have been running that amount of memory at that speed on a live streaming PC, on a production PC, with 100% stability. I've been doing that for like 2 weeks. Recently, I took 2 of the sticks out because I wanted to test tightening timings and running the memory at higher speeds. So currently I'm running 2 sticks of 48, so I'm running a total of 96 gigabytes at 6400. So we're doing 6400, 96 gigabytes, and we have tightened the timings. So I'm running like CL32 or something, and then like TREFI is like 40,000 plus or whatever currently right now with 96 gigs. Now, I did not try to do that with 192, but what I can tell you is 192 on the current motherboards with a Zen 5 CPU can do 5200, no problem. What I'm hoping is that these newer motherboards allow for 56 to 6000 consistently. I would say 56 to 6000 with 192 gigs on a X870E flagship board, like this Godlike, for example. I think that should be doable because if you guys, we're going to look into it. We're going to watch some of the video from MSI in a little bit, but what they talked about is on the Godlike, and this also applies to some of their other ones. I think like the Carbon Wi-Fi also got this. The Godlike in particular is a 10-layer 2-ounce copper PCB. So they were talking about how they improved wire trace layout. And that is a very good thing to hear if you're someone who's interested in running high-speed DDR5 or even just a lot of DDR5. Because the thing that they have learned, they being the motherboard manufacturers, is that the wire layout for the memory lanes is very important if you want to run a lot of DDR5. And why is this a challenge with DDR5 compared to DDR4? Because the frequencies are so much higher. Think about it. We're talking 6,000 megatransfers or higher, you know, with 2 sticks. With DDR4, like most people were running nowhere higher than like 3,600. So we're talking 3,600 versus like 6,000 plus. That is the reason why the trace layouts, the resistor values, the impedance values, the resistivity variance, the bus termination, that is the reason why the wires, the individual physical wires that run from the CPU socket to the memory is so much more sensitive and so much more important in order for you to run a lot of memory, because the frequency is so much higher than DDR4. So that's the reason why. So they've taken a lot of those learnings from the first generation of DDR5, so in this case like X670, and this also applies to Intel's motherboards too, because like I said earlier, Z690 to Z790 saw a huge improvement in terms of the maximum memory speeds that you could get on the Intel platform. So this will, I expect the exact same thing to apply to the newer AMD motherboards as well. But what I can tell you guys is, you know, like typically if you're running 2 sticks can easily do 8,000 on current X670E. As long as you have like an 8-layer PCB, you can do 8,000, no problem. It's when you run 4 sticks, 4 sticks is really the only challenging thing. Particularly 4 sticks of dual rank, but even 4 sticks of single rank, if you have a lot, if you have like the higher density, like for example 24 gigabyte DIMMs. So if you do, like, think about this, 4 times 24, that's 4 sticks of 24 each, that's 96 gigabyte total. That is also hard to run above 6,000, but that can run at 6,000. I have proven that, I've shown that. So with 100% stability. So it's really the 128, the 192 gigabytes. That is the real challenge. Like 8,000 on like 32 gigs total or 48 gigs total, that's easy. That is just straight up easy mode. You don't need an X870E to do that. So, but will it run 8,000 MT11? No, it won't run MT11. That's impossible. That's physically impossible. And that's because the memory controller cannot run at 4 gigahertz. You have to think about what you're asking the memory controller to do. So no one is expecting 1.1. That's called unrealistic expectations. So whenever we're talking about 8,000, we're always talking about 1 to 2. Because think about how fast the memory controller is running when you're running in 1.1. Think about that. I don't think a lot of people think about how fast the memory controller is actually clocking. And I think they're getting there's a little bit of some misunderstanding. So the unified memory controller, also known as the IMC or the integrated memory controller, this typically runs, so if you're 1.1 and let's say your M clock equals 3,000 gigahertz, or megahertz. This is 3 gigahertz. So keep that in mind. 3 gigahertz for a memory controller. Remember, this is not a core of the CPU. This is not something that is supposed to clock super high speed like a core. A core on a Zen 5 can clock to like 5.5 to 5.7 single thread boost. But this is a memory controller. A memory controller is not designed to go well beyond 3 gigahertz. And this is the reason why everybody says, you know, 1.1, and this is the reason why people say 6,000 megatransfers is a sweet spot, because 6,000 megatransfers means your memory is clocked at, your memory controller in this case, we're talking 1.1. 1.1 means U clock equals M clock, which equals 3 gigahertz. See, so you're asking the memory controller to run at 3 gigahertz. Now, the reason why 8,000 is actually easy to do, because when we're running in, let's say, 1 to 2, so if we're at 8,000 megatransfers, that means U clock equals 1/2 M clock equals, well, let's not put that. Actually, yes, let's put that. So half of the M clock would be, so where the M clock equals 4,000 megahertz, which means, you know, U clock is half of this, which means U clock equals 2,000 megahertz. This is why 8,000 is not that hard to do. This is why I tell people, if you want to run 8,000, it's actually not hard. You just have to get RAM that can actually clock 4 gigahertz. That's the challenge. You got to get RAM that can handle running at 4 gigahertz. Because the U clock, the IMC is just relaxing. It's sitting back at running at 2 gigahertz. Which means when you're running 1.1, and your RAM is at 6,000, your memory controller works harder because your memory controller is running at 3 gigahertz. When you're running at 8,000, your memory, the memory is working harder because now the memory is clocking a whole gigahertz faster than when it was at 6,000. But the memory controller, the IMC, is actually relaxing. It's actually like, oh man, I can slow down. I don't have to run so fast. So that's the reason why I kind of think 8,000 is actually pretty good, because at 8,000, like if F clock is also 2,000 megahertz, this means that the synchronization between the fabric and the memory controller, it's fully synchronized. It's 1-1, meaning you now have 1 to what? 1/2, I guess? Or it's like 2 to 1 in terms of F clock. See, it's like F clock ratio, U clock ratio, and mem clock ratio. Does that make sense? See, so that's why this is actually not that hard to do. Now, the thing is, when you run your RAM at this speed, you have much faster RAM. So your RAM is less of a bottleneck than when it was at 6,000, in the sense that your RAM has more bandwidth at 8,000 versus when it was running at 6,000. So that's why it's still beneficial to run the RAM at 8,000. And a lot of people seem to think, oh, well, X3, what if you're running X3D? X3D doesn't need 8,000. That's mostly true, but if your game or your application is still very memory hungry or memory dependent, then the faster memory still helps. And I've proven that. I've shown a video. It's not a whole lot. Like with X3D, the difference between 6,000 and 8,000 on an X3D is like in the neighborhood of 2% average FPS. It's 2% faster on 8,000. And the minimum, the 1%, the 0.1% and the minimum FPS is about 4% better on 8,000 versus 6,000. So there is a small benefit to running 8,000. versus 6,000. But most people don't want to spend the money if they don't have to on 8,000. That's the main reason why. Okay, so good question. So let's go back here real quick. Okay, so what do we want to talk about here? I guess, do we want to talk about, I see some comments on 5090. Someone's asking me if I have an RTX 5090. I don't know how to answer that question. I don't, is that a sarcastic question? Is that a rhetorical question? I don't understand. That's a really weird question. Do I have an RTX 5090? How should I answer that? Like, I don't even know how to answer that question. Anyway, do we want to talk about the RTX 5090 first? Do we want to talk about this? You guys want to talk about RTX 5090? Or just the RTX 50 series in general? Or should we keep talking about RAM? I see some comments about RAM. Secondary timings are more important. Yeah, if you're someone who bothers changing those. Not a lot of people do that. But I will say, like, some motherboards, like Gigabyte, for example, Gigabyte does have a, I forget what they call it in the BIOS. It's like low latency or performance expo XMP, whatever. You turn that on, and then it adjusts the secondary, tertiary timings for you automatically. And that's what I've done. I mean, I'm running that enabled on mine now. So, but yeah, otherwise, like, there's no guarantee. Like, it's a lot of, if you're going to mess with the secondary timings, that's going to be trial and error, because unless you know how to actually test stability for memory long term, you know, that's not guaranteed. Cast latency and overall latency. Yeah. That goes down when you tune the timings. Basically, what Met's talking about, secondary timings are more important. Yeah. You can do that, but like I said, that's going to be a lot of trial and error. Oh, no, we are going to talk about it. I don't know, like, if you actually thought that I had one. If I actually had a 5090, I don't think we would talk about the 5090, because let's put it this way. If I had a 5090 from NVIDIA right now, if I had a review sample, for example, I wouldn't be able to talk about it because I'd be under NDA. So let's put it this way. If I had a 5090, the title of this video would not mention RTX 5090. Like, that wouldn't even be in the title if I actually had one, because I'd be under NDA. But do we want to talk about this? I don't want to spend too much time on the 50 series because it hasn't officially been announced yet. So there's not a whole lot to say, other than to say that these claims are garbage claims, and anyone who thinks that I don't like articles that are titled like this, because these kind of articles are what I consider spreading misinformation. Like, this is the sort of clickbait article that causes people to get confused. Like, this creates confusion because this is not true. Like, this is totally not true. Do you guys remember when the 4090, 2 years ago, when the 4090 rumors started going around and everyone was like, oh, it's 600 watt, it's going to burn your house down, blah, blah, blah. And then that turned out to be completely false, because the TDP was like 450 watts. It wasn't even close to 600. What they really meant was the connector is rated for up to 600 watts. That is what they meant. And that's most likely what this is actually referring to, meaning the connector for the 5090 will be rated for 600 watts, just like the 4090. That's all this means. This stupid power reportedly at 600 watts, this is what I call fake news, because that's not going to happen. It's not going to be a 600 watt TDP card. I mean, it's just not going to happen. If you had a 5090 Ti, would it be like Fight Club? 600 watts would require 2 power connectors since one would have... I don't think it would require it, but I don't think Nvidia would be dumb enough to release, like if the card was going to normally boost outside of 450 watts, for example, like if it was going to go to 500 watts, for example, I think it would be very foolish of Nvidia to only have one 12-volt high-power connector because of what happened, as we know, with the 4090 and all the melted connectors, which that has been a problem for the entire lifespan of that card, and it is still a problem today, and no one has actually done anything to fix it, and it's just kind of sad that that's the reality, that a $2,000 GPU can have a melted connector problem. So, 400 watt for the 5080. So, I guess, what are they talking about here? Are they talking about, like, peak power draw, or the connectors rated for this? Like, this is what I call fake news. Like, what does this say? So, Kopai 7 Kimi, I know you someone got the details of GeForce of Blackwell recently. Both of them all have some increase in power consumption, with higher SKUs increasing more. Okay, yeah. That's pretty obvious, right? Like any sort of Galax Hall of Fame or Supreme from MSI, all those cards are going to increase the power consumption. Oh, that's such a novel idea. Like I never would have expected that. Wow, that's such a leak, man. Wow, that's cool. I would have never guessed. that the Strix could pull more than the reference. I say 550 watt for the 5090. More, okay. So 600 watts for the 5090 and 400 watts. Yeah. Okay, yeah, no. That's not true. I can tell you right now that's not true. Basically, the TDP on these 50 series cards are basically going to be the same as the last generation. So it's going to be 450 watt for the 5090, just like the 4090. And then the 5080, I mean, that could be like, what, 350 watt TDP or something? Like, it doesn't really matter. It's going to typically be like 100 watts less than the higher tier card. That's typically how they always do it. So I don't see that being any different. Although this article seems to state that the 5080 will be rated at 400 watts, which is 80 watts higher than the RTX 4080 and 4080 Super. This is an increase of 25%. It is also said that the GeForce 5070 will be rated higher. Okay, well, whatever. And then the... okay. Okay. Yeah, this is nonsense. This is kind of a dumb article, because this is not true. Yeah, Nvidia's not dumb, guys. Like, think about it. They've already been blasted for the melting connector problem. Do you really think that they're going to launch a card that regularly pulls more power than the 4090 when the 4090 already had problems with melted connectors? And the thing is, they can't exactly change the spec for that connector because the power supply manufacturers basically built all these newer power supplies with that connector natively on there. So what are they going to do? Make a new connector and then invalidate like all the power supplies that were sold in the last 2 years? No, that doesn't make any sense. Just like how Red Gaming said that the Zen 5 would have the 30% IPC. If they use the same 12-volt connector, again, Nvidia are disrespectful. No, I think they could use the same connector. They would just have to put, like, 2 connectors. Think about it, guys. Think about it. It's not bad to use that connector. Like, they can just do 2 connectors. So, let me just put this over here for now. I may delete that later, but anyway. So, if you have the GPU like this, right? And you have the connector right here. Like, if this is the connector, if this is the skinny little connector that can melt. So they give you in the box, when you buy one of these GPUs, you get the adapter thing, and it has it's got like four things, right? Like, it's got four 8 pins. So that is 150, 150, 150, 150. So this is the way the 4090 works currently. You got 150 watts times 4. That's 600 watts. Right? Now, what they could do with the 5090, let's just assume the 5090 is a cinder block. It's like thicker than the 4090. So what they can do, instead of putting one connector, they can put 2 connectors. You know the easiest way for NVIDIA to solve the burning connector problem? Put 2 connectors. 2 connectors. You know what it's called? You know what we call this? Load balancing. They can implement something called load balancing. So in the box with the 5090, they'll include 2 adapters. 2 adapters that have 2 8 pins each. 2 8 pins each. So you still have the total, that stupid article saying 600 watts. 600 watts. Oh, it's still going to be 600 watt capable. But if they put 2 of the 12 volt connector and they load balance across both of them, now it's much safer. Because now the maximum power draw for one of these connectors is only going to be 300 watts. And the other one can handle the other 300 watts. The reason why this has been such a problem is because you're forcing potentially up to 600 watts, or in some cases more, through one tiny little connector with really skinny small pins. You know, compared to the old 8-pin PCIe, the little pins on this newer connector that NVIDIA and Dell had invented together, it just looks like bad news. So, guys, like, they're probably going to do this. And they're going to be like, guys, it's safe to... You know what? I can see it now. Jensen is going to open his oven. He's going to pull out a graphics card. I don't have one with me right now. Let's just pretend this Ryzen X3D is a graphics card. He's going to pull it out of his oven, and he's going to be like, guys, check it out. RTX 5090. Dual 12 volt connectors. It is safe for you to upgrade now. That, for my friends on Ampere, for my friends on RTX 3080, it is safe to upgrade now. That is exactly what the messaging is going to be. That is exactly what the messaging is going to be. So, yeah, that's all they got to do. Problem solved. There, I solved the problem without even seeing the product yet. It's that simple. It's so easy. It's so easy. Put 2 connectors. You know what the easier fix is? Don't force the AIBs to use that stupid connector. Let them do what they did on 30 series. Because if you guys remember, 30 series also had some stupid custom connector that was not the standard PCI connector. You guys remember that? Anybody who had a RTX Founders Edition 30 series card, like a 3090, a 3080, even I think the 3070 and all those other Ampere cards, they all had that random little custom connector, which I might add is not the same as the connector that the 4090 and the 3090 Ti used. So, but they didn't mandate it, which means if you bought like an EVGA 3080 for the win, like those things had like triple 8 pins on them. You know, like those things had like the big old classic, the classic. These had like the classics on them. You know what I'm talking about? It has some classic connectors. Like these are the built Ford tough. You know, like these are the ones that like they can take it. They're not gonna melt. They're not gonna burn your house down. So like that's why the 30 series never had this problem, because most people had a standard graphics card that had standard connectors, tried and true, not some beta tester fiasco with like this thing, and so they didn't have this problem. So anyway, this is the easiest way. I've given NVIDIA the solution, guys. Like, I've given them the solution. Whether they decide to do this or not, I mean, that's up to them. But that would solve the problem. That would make this issue literally go away forever. Anyway. If they put two connectors on the 5090, then the clickbait news will say it draws. No, it won't. It won't do that. Anyway, because of the breakers. Anyway, X870 is going to be the move. File a patent. I should file a patent for this. I would. Unfortunately, Galax already beat me to it. Galax already beat me to it, because if you guys may not be aware, Galax has a Hall of Fame. Let me see if I can find the card actually. Hold on. Let me see if I can find it. Hold on, what is it called? Galax. RTX 4090 Galax. Where is it? G for where is it? Hall of Fame. This one? Is it this one? Yeah. Found it. Okay, this... The reason why I can't file a patent, someone beat me to it. Check this out. Oh, wait. Why can't it... See? Look at that. Someone was already smart enough to do this. Look, this card has two of those connectors on it. So this card's not going to have the melted problem, because they did it right. This was basically a 5090 without even knowing that the 5090 was going to probably do this. I mean, assuming the 5090 actually does this. But anyway, that is the way you solve the problem. And it's not that big of a deal when you think about it. Someone's like, well, oh, that's going to require like so many... That's only going to require a high-end power supply. Oh yeah? Like as if the regular 4090 didn't require a high-end power supply? I mean, this is only going to require 4 8-pins. 2 8-pins per connector versus 4 8-pins per connector on you know, like the standard one. So anyway. The Hall of Fame cards were oil paintings. I don't understand this though. Like, what's up with this extension that hangs off the... Is this meant to be mounted vertically or something? Like, how many people actually mount graphics cards on risers though? Like, I feel like almost nobody does that. I mean, I guess if you have one of those, what I call the fish aquarium computer case, maybe you would mount it vertically. I don't do vertical mount GPUs. I just think it's lame. It's so impractical, especially someone like me who's constantly changing out hardware all the time. No. That's why. That's the reason why I don't do custom loops. I don't do custom loops because I swap hardware way too often. Like, I don't want to keep tearing up the loop. You know, like having to pull the CPU out of the socket, remove that thing. Well, actually, soft tubing, it's no problem. I've thought about doing soft tubing. I would never do hard tubing because I change hardware too often. But I have thought about doing a custom loop soft tube based build. But I always think about doing it, and then I'm like, I'm probably only going to be using this graphics card for like 2 months. We're going to swap to a different one to test a different one. So it's like, yeah, no. I mean, that's the main reason. But maybe like on the CPU. I might do consider doing soft tube custom loop for the CPU. Just the CPU, not the graphics card, though. The power limit on the Galaxy is 666. Wow, they're really tempting fate. They're tempting fate. They make their max power draw 666, but you know why they're okay? Because they put 2 connectors. They put 2 connectors, so they don't have to worry about anything. Custom loop is dumb, especially... Yeah, that's why I have never done it. I've never done it because of those reasons. For all the reasons I just mentioned. But yeah, 50 series... This is going to be an interesting launch. You know what's funny, or what not? It's not funny, but what's interesting with the way things are going for these chip design companies like Nvidia and AMD is they're not able to leverage the full benefit of a traditional node shrink. So I think part of the thing, and I said this in my review of the 9950X. If you haven't seen my review video, it went live on the channel like I think yesterday. So I said this in the conclusion. What was interesting about the Zen 5 launch, and I think we're going to see similar things with the upcoming launches for other computer parts. A lot of these generational uplifts that we're used to seeing are due to a combination of new architecture and a node shrink. In the case of Zen 5, they didn't get the node shrink. They got the new architecture, but they didn't get the node shrink. And when you don't get the node shrink, you don't get the benefit of just being able to throw more transistors at the problem and just get the performance uplift by default. So you have to get more creative with how you design your product because it's going to be on the same node effectively. And this is kind of like Nvidia had this problem back when they went from Kepler, which would have been like 2012, 2013, to Maxwell, which was 2014, 2015. So if you guys remember the GTX 980, when it came out, it was not that much faster than the 780 and the 780 Ti. And Nvidia had to do creative things with Maxwell to get as much of a performance uplift as possible. And one of those things they did was they introduced Delta color compression. The other thing that debuted around the Maxwell launch was G-Sync back in the day, for those that may not have been aware. But so they marketed the 900 series with newer features like G-Sync and the module that was in the monitors, and Delta color compression was something that gave them a noticeable uplift. And that was pretty much it. It was more energy efficient, but it wasn't that much faster. So they went for the efficiency play plus like newer ways of doing things in software compared to the previous generation. And that's how they were able to get their uplift. Similarly, AMD has had to do that with Zen 5 because they're pretty much on the same node. So what do? Oh, they widen the data path for AVX 512. So AVX 512 performance is better. But the reality is not a lot of software applications use AVX 512. So you don't really see a lot of uplift that you would expect. The other thing too was they improved the branch prediction. But again, like that, there's a dependency on software to take advantage of that. So I think where Nvidia was able to mask some of the deficiencies with Maxwell versus Kepler in terms of uplift, they were able to do that because they had control over the software driver stack. Now, it's different when you design a CPU, because when you design a CPU, you don't have control over how applications are going to use the CPU, because the CPU is effectively just like, it just sits there and it processes a bunch of things for different applications. Whereas the graphics card has the whole driver stack, which is a whole different animal, and NVIDIA and also AMD, like anyone who makes GPUs, they have more control over how they can optimize the way the hardware is utilized by applications under the hood, whereas a CPU doesn't really have that luxury. So yeah, it's interesting. Without node shrinks, we're gonna see these sort of product launches where you don't really see a huge performance uplift compared to when you get the node shrink. This is very similar to if you guys have been building PCs for a while, you'll remember that the Intel used to have this. They used to have this thing called TikTok. And I know I say TikTok because everyone thinks, oh, TikTok, like, the social media streaming site, that thing. Well, I'm talking about like Intel's strategy for product launches based off of Moore's law. So the talk meant new architecture. The tick meant new node. So the way Intel used to do their product launches was if they were on a talk cycle, they were doing a new architecture. If they were doing a tick cycle, they were doing a new node shrink. So if we think about the Intel products here, let me clear some of this stuff on Paint Up. Let's get rid of this GPU stuff. Here we go. So if you guys remember, what was it? 2011 was Sandy Bridge. This was the talk. This was the talk. This was 32 nanometer. Then in 2012, they did Ivy Bridge. This was the tick. This was the drop to 22 nanometers. So, that meaning Ivy Bridge was roughly the same as Sandy Bridge. It was basically Sandy Bridge on a newer node, which means that all the improvements that Ivy Bridge got was from the node shrink, whereas Sandy Bridge was the new architecture on 32 nanometer. And then if we go further, we talk about Haswell, everybody's favorite Haswell. Haswell was probably, okay, I know Sandy Bridge was a very memorable architecture from back in the day, but Haswell was really the one that made all the headlines because this was the one where Intel started using, no, was it Ivy Bridge? It was one of these two. Intel started using toothpaste instead of actual solder between the CPU die and the IHS. It was one of these. It was either Ivy Bridge or Haswell. I know Haswell definitely had the toothpaste. I forget if Ivy Bridge had the toothpaste. One of them had toothpaste. But this one was the one that did the fiver. The fully integrated voltage regulator was on the CPU, and that's why it ran really, really hot and had problems. But this was the talk, and this was on 22 nanometers. So, again, like here, you had a new architecture, but it was the same 22 nanometer node. So all your uplift was on the node shrink, or on the architecture change. So think of it like, okay, if we fast forward to like AMD, right? If we're talking like Zen 4, or if we do, let's just skip right here. Let's just do like 2022 Zen 4, and this was the talk, and this was, what was this? This is 4 nanometer, 5 nanometer, somewhere around there. This was the, oh no, this is the tick. This is the tick, because this is the node shrink. They got the big node shrink coming off of Zen 3 going to Zen 4. They got the node shrink. But it was mostly like Zen 3. The only difference was Zen 4 could do like AVX512. And because of the node shrink, because it was such an advanced process for TSMC on the 4 nanometer, they were able to clock so high. And that's the reason why you saw a significant bump from Zen 3 to Zen 4. But now if you look at Zen 5, this is Supposedly, this is the talk, because it's a new architecture, but it is the same node, so it's kind of like, it's very much like this. It's a lot like this. Anybody who was on Ivy Bridge at the time, any one of you who had an i7 3770K, because this would have been the i5 3570K or i7 3770K. And then these were the i5 4670K or i7 4770K. So anyone who had these processors, they didn't have any real reason to upgrade to these, even though these were on a new architecture. So it's the same thing with AMD. Like, it's literally the same thing. Like, we're running into that same problem now, where, and it's actually getting harder and harder to get these node shrinks. So it's gonna be really interesting to see what happens if a company like TSMC can't deliver a performance uplift. Because this is kind of like, this is what you can expect. This sort of thing. Because a lot of people are like, oh, well, Intel stagnated during this time. Well, I mean, yes and no. In the sense that they basically were doing this thing where they would introduce a new architecture, then they would give you a node shrink version, then they would introduce a new architecture. You know, like, they would do that. I think we're getting to the point now where, because the cost of the research and development for these node shrinks, because we're really coming off of nanometers now, and we're having to move into the era of angstroms for the process technology. And we're going to talk about Intel next, which is why I kind of wanted to foreshadow the discussion about Intel, because that's why we talked about Sandy Bridge, because the node shrinks are going to be much harder to get. So, and you're going to have to wait longer to get them, because it's becoming much, much more challenging to keep shrinking the transistors down. So this is what's probably what's going to happen for the next 5 years, until there's some kind of insane breakthrough in processor, like, wafer fabrication technology. I think we're going to expect these kind of uplifts for the next 2 generations of processors. I could be completely wrong. Now, I mean, I know TSMC has more advanced nodes. I know Intel has been working on newer nodes. But the problem is Intel has been running into a lot of problems with their manufacturing, and it's gotten so bad and so challenging for them, apparently, that they have had to utilize TSMC for their next generation on consumer. Now, they refuse to do that on the data center and the enterprise, because they can't get the volume quantities that they need. And if they have to keep buying from TSMC, their profitability is going to go down dramatically. Otherwise, they're going to have to pass the cost off to the consumer, and they can't afford to do that because there's too many competitive options from AMD and now Qualcomm with the ARM processors. So Intel is in a weird spot right now, which we've talked about before, but we're going to talk about Intel here in a little bit. Intel also makes their own CPUs, I understand. That's where it gets interesting, because they have, but now they're splitting. Now they're actually splitting. So, that's a good segue, actually. Let's look at, what was the article? Hold on, let me find the thing. Where was it? See, like, okay, this is not the article I wanted to look at, but this is one of them. There was one for... Where is the one about their thinking about selling? There was a rumor that Intel was going to sell, like, spin out their fab I don't think they're going to do it. I think it would be foolish of them to do that, but I can see why they want to do it. So, Intel's foundry business fails to impress Broadcom with latest 18 angstrom process. So this is an article this is not the article that I was looking for. There was an article that was a rumor that Intel was considering spinning off their manufacturing. Basically, the article said that they were potentially looking at selling off their fabs. Basically, what AMD did a long time ago in the mid to late 2000s. So almost, like 15 years ago now, AMD, I think it's around 15 to 20 years. I forget when exactly AMD sold off their fabs. But AMD spun off, so a lot of people may not know this. AMD used to also make their own CPUs. But they sold off their manufacturing division and they spun it off into a company called Global Foundries. And they used, and kind of the agreement was that they would use Global Foundries as their primary supplier to manufacture their CPUs. So they were doing that for many, many processor generations until Zen 2. I think it was Zen 2, they basically went to civil court, they went to like divorce court, and they got a divorce. Essentially, what they did was AMD divorced themselves from Global Foundries. So they didn't have to use Global Foundries for like all their CPUs anymore. So what ended up happening, if you guys remember, when AMD introduced chiplet design with Zen 2, you guys may have forgotten this, but the CCD on Zen 2, aka Ryzen 3000, was made by TSMC. However, the I/O die, which includes the memory controller, the Infinity Fabric, all that stuff, that was made by Global Foundries for Zen 2. Now, after they got their divorce, they immediately went to TSMC, and TSMC started making everything for the AMD CPU. So it did the I/O die, it did the CCDs. So Zen 3, Ryzen 5000, that is the result of a full TSMC fabricated processor. So, and you guys notice the difference though. Notice when AMD all of a sudden became really competitive with Intel. It was when they went to TSMC. It was when they finally got away from using Global Foundries and they went to the most advanced node, and then they started getting more competitive. Same thing with their graphics cards, because a lot of people forget AMD was also using Global Foundries to make their Radeon cards. In fact, if you guys remember, the RX 480, so if we go back here, the GPU, let's look up RX 480. RX 480. This was made by Global Foundries. Global Foundries, 14 nanometer. So it's a miracle that they were competitive with NVIDIA with the Global Foundries node. The fact that this thing was competitive with GTX 1060 at the time is amazing, because GTX 1060 was on TSMC 16 nanometer FinFET at the time. So, but you guys remember, as soon as AMD started going to TSMC for the graphics cards, we know what happened. Do you guys remember the 6000 series, RDNA2, 6900 XT? I don't think anybody expected 6900 XT to beat the 3080. I don't think anybody was expecting that, but the fact that it did, I mean, that was wow, okay. See, so the node actually matters. A lot of people think, oh, AMD and NVIDIA, they don't give the foundry enough credit. I feel like the foundry is really the arms dealer here, because without the foundry being top notch, you're not going to have a very competitive product. So, I mean, that's the reason why, like, everybody and their dog and their brother and their cousin are all going to TSMC to make their PlayStation 5 Pros, for example. Like the PS5 Pro, which we're looking at right here. Like, these things are all, like, TSMC fabricated now. So, I mean, and the sad thing is, I really want to see other foundries step up and be competitive with TSMC, because that will help bring the prices down on all this hardware, and that can help advance technology faster. Otherwise, we're getting to a point where everything is funneling through one company, in this case TSMC, and it's like now they pretty much determine the destiny of humanity in some weird psychological way. Because when you think about it, if TSMC fails, the entire chip, I mean, unless you're trying to sell like washers and dryers and refrigerators or something, you know, like random IoT devices that don't need to be on the cutting edge node, like, humanity just doesn't advance, because it's like you lose this, you don't, you know, you're not able to advance technology fast enough anymore. You hit stagnation if that happens. I mean, that's the whole... Now, this is going to start going off geopolitical, so we're not going to get into that on this stream, but you guys get what I'm saying. Like, the foundry doesn't get enough credit. Like, a lot of people think about, oh, NVIDIA and AMD and all these guys and Apple making iPhones and all this stuff. Well, yeah, it's like, yeah, they can design their chips, but if TSMC can't build their chips, like, I don't know what to tell you guys. I'm sorry, but you're not going to have your fancy 5090. So the node foundry provider matters a lot. Like, these guys actually probably arguably matter more than NVIDIA, AMD, Apple, you know, all these guys that can try to sell you their fancy hardware. Samsung held back Ampere performance. Yeah, but we have seen NVIDIA unleash the full power of TSMC, aka RTX 4090. So, yeah, ASML is also in there too. Yeah, I forgot to mention ASML. Yeah, if you don't have the guys that make the equipment that these guys use, then yeah, you're pretty much screwed as well. So it's like ASML and TSMC, these two companies, they don't get enough credit where credit is due, because everybody likes to focus on the end product, right? Like, everybody likes to focus on the shiny GPU, the shiny product, the PS5 Pro. Where's my PS5 Pro? Come on, Sony, what's taking you so long? You know, like, everybody has that mentality. But at the end of the day, if TSMC can't deliver, everything's screwed, pretty much. Like, the whole market, it just falls over. It just topples over. You know what I'm saying? So it's like, man, it's crazy. So anyway, yeah, so that's, I guess that covers RTX 5090. Like, 5090 is completely dependent on TSMC. Like, NVIDIA is so dependent on TSMC, like, it isn't even funny. AMD also, like, trying to be as competitive as possible. They have also now become fully dependent on TSMC. And the funny thing is, Intel... Oh, wait. RMA... Hold on, this is not the story that I wanted to talk about. Intel looks for options to get foundry business like to get massive hit. See, okay, I think this might have been the article. When you see stuff like this, when you read headlines like this is not good news. Like, this is very bad to see, because this just shows that this business is so competitive that there is, like, almost no room for error. And if you're running into problems like what's happening here, it's just not good. I mean, it's just not good. And on top of that, they have, like, they have basically split their product lines now. Like their business customers are still going to get products that are built by Intel's own foundry, but the consumer market is like, for example, the upcoming, well, they just launched it actually, Lunar Lake. The Lunar Lake in laptops, all their newer CPUs for consumer, those are going to actually be made by, you guessed it, TSMC. So it's like they're actually using TSMC for a good part, a good percentage of their consumer products now. Like their graphics cards are also made by TSMC. Like they were never made by Intel, like in terms of the foundry business. So what's still going to stay Intel Foundry is the servers. So the Xeons, and they've got these weird, like Intel is splitting their servers. So within the server market, they have I think they have they're calling it Xeon ASP and Xeon ISP, which I don't know what ASP and ISP stand for, but the way it was explained to me from Intel, like Intel literally told me that don't say, like when you're talking about our products, don't say P core and E core, don't say performance core and efficiency core, because like they were telling me that efficiency core carries a negative connotation, and I was like, I don't know if that's true. Because especially if you're talking to data center customers, like they want your product to be efficient. So if you tell them it's an efficiency core, they might actually like it. But they kept telling me don't say efficiency core. Like people don't like to hear that. So I was like, okay, so then what do I call it? And they're like, oh, ASP means performance core only, and ISP means efficiency core. But it's like, okay, what does ASP stand for? They didn't know. So I don't know. ISP, they don't know. I don't know. But whatever, they're basically splitting their server processors so you can buy a Intel Xeon that only has the big cores, and then you can buy like another type of Xeon that only has the little cores. So they're doing it like that, and both of them are made by Intel's foundry business, not TSMC, not Samsung. No, they're still made by Intel. However, if we're talking Lunar Lake and the whatever, like the other stuff, like the laptop business and all that stuff and handhelds, those things have Intel logos on them, but they're actually made by TSMC, which means it is so bad, like it is so hard for them to do this. Like, they actually have to go to their competitor. Because TSMC is their enemy. The fact that they have to go to their opponent and be like, they have to wave the white flag and be like, hey, can you build my thing for me? I won't attack. It's like, time out. Can you build this for me? Like, I can't put it together. I don't know how. Like, that's basically what it looks like. It's kind of sad. It's like, hey, I made this chip. I mean, I designed this blueprint, but I can't actually physically make it anymore. Can you make it for me? Like that's what they're basically asking TSMC to do. Like, that's how bad it's gotten. So, yeah, I don't know what that means for them long term, but the fact that we're seeing rumors that they're thinking of spinning out their foundry business, because I'm guessing Pat has not been able to get enough people to use their 18 angstrom or 20 angstrom. In fact, I think they actually skipped their 20 angstrom. I think they're literally pulling the plug on that, and they're going straight to 18A because of some whatever. I don't even know what the excuse is this time around, but it's like every time I read up on Intel's foundry, there's always some kind of excuse. It's like, it's too challenging, it's too hard, the yields are bad, there's something wrong, like there's not enough water in the plant to, something was contaminated. Like there's all kinds of weird, like I don't know what's going on, man. Like if I was the vice president of the foundry business, I would resign. Like I wouldn't even stay. I'd be looking for another job, because every time I read something about Intel's foundry, it's always bad news, and it's it's not good. And I don't want them to fail because I don't want everything to just be dependent on TSMC. That's like the worst thing that can happen. You want other companies. Can you like think about it like this? This is like, okay, if Intel Foundry goes away and everything is made by TSMC, this is like if AMD stops making GPUs and Intel stops making GPUs, and then Nvidia's like the only supplier of graphics cards. Like, how is that good? Like, how exactly is that good? See, like, you don't want, you basically don't want a monopoly, because then what ends up happening is the government will be like, hey, you're too big. You need to split up, or we're going to split you up automatically. And you don't want that. So you don't want somebody telling Jensen, you don't want Uncle Sam telling Jensen, hey, you got to break up your company into like 5 different smaller companies because you're too big. Like, that's not, you don't want that. That's not good. Because then they're going to be like, okay, we're going to do a software company that will do CUDA and all the AI. Then we're going to do a chip design only company. Then we're going to have another company that does like automotive and work with like Tesla and heavy industry stuff. You know, like Nvidia's large enough that they could break up successfully into like 5 companies and they'd be okay. But I would rather them not do that, because like, why does that have to happen? You know what I'm saying? So yeah, you don't want these things to actually fail. Like, that's the bottom line. Failure is bad. It's a bad trend. All right, in other news, we're not going to spend too much time on this, but let's talk about PlayStation 5 Pro, because there have been a lot of rumors recently on PlayStation 5 Pro. And this is probably the next big hardware announcement that is adjacent to what we talk about on this channel, and it is also a gaming-focused device, so it's worth talking about. But the PS5 Pro, it's rumored to be announced next week, which that could very well happen. Remember, guys, I told you guys probably for the last 3 months, I've been telling people, the last thing I said was if it doesn't show up at Gamescom, which was last week of August, then it will probably be announced at Tokyo Game Show, which is happening later this month. So if it's announced next week from Sony's own State of Play, then that's totally fine. They can do it that way as well. But then they may actually have units in the booths at Tokyo Game Show. So either way, it's either going to show up next week or it's going to show up at TGS. Like, I expect it to be announced. So we'll see how accurate I am, but I'm going to go ahead and make like a declaration here. This thing is going to be announced in September, and it's going to launch in November. So September will be the announcement month. November will be the actual month that you can purchase one. So I don't know when they're going to do pre-orders. Maybe pre-orders open up sometime in October, or maybe sometime this month. But in any case, I don't know how many people are actually going to get this at launch. I don't know what the supply is going to be like. If I had to guess, I think it's going to be $700 and $600 for the digital only. So, yeah, Marcelo's saying $699. Yeah, exactly. I agree. I think it's going to be $699 with the disc drive. Now, if they have a digital-only version that has no Blu-ray drive, that one will probably be $600. But the one with the Blu-ray drive, which is the one that I think most people want to get, if you're someone who is in the PlayStation ecosystem and you want to be able to play GTA 6, for example, like at release when it comes out, because it's not going to come to PC at the same time. People who want to play GTA 6 on PC are going to have to wait like a whole another year or whatever. So that crowd of people, the PS5 Pro is going to be the best way to play GTA 6 initially. And they're probably going to want the disc version. It depends, because I know a lot of people that they play a lot of games on PC. Like I myself, using myself as an example, I typically play games on PC. I don't really play too many games on the console anymore. But for the games that are console exclusive, whether they're timed exclusive or they're exclusive, like for example, Demon Souls remake, it's still PS5 exclusive to this day. That would be an example where I have to play it on PlayStation 5. And then other games like, for example, Final Fantasy 16 that came out last June, last year. It's been over a year since Final Fantasy 16 came out, and I was not going to wait until the PC release, so I had to play that on PS5. And then likewise, Final Fantasy VII Rebirth was another game that I played on PS5. So there are a couple of examples, like I think God of War Ragnarok, Horizon Forbidden West was PS5 for like more than a year. So unless you were okay with waiting around until like after the hype is gone and whatever, then you would typically play it on PC. But like some of those games, I'm not gonna wait. Like other games, I can wait. But those Final Fantasy games, I'm not gonna wait for the PC release. So that is the reason why I have the PS5 for that reason, because I'm not gonna wait around, man. Like, you think I'm gonna wait to play Final Fantasy 16? Like, by the time it comes to PC, like it's coming to PC only later this month. But like pretty much all the people that wanted to play Final Fantasy 16 already played it, and all the diehards already platinumed the game. So it's like now it's coming out to PC. It's like, okay, I kind of think that this is kind of an underhanded way for the developers to kind of double dip, if that makes sense, because sometimes people will buy the same game and play it again just because they haven't played it in such a long time. So, like, can you imagine if Bloodborne, for example, which is still a PS4 exclusive to this day, can you imagine if that gets announced for PC? Or they have, like, this remastered version that's like PS5 for like a year, and then it comes to PC like the following year. Like, I feel like developers they can get away with doing that because it kind of staggers it out. So like people who played it way back in 2015, they'll have nostalgia, and the marketing train can build up hype for them to get it on PC or get it on PS5 Pro and just play it again, like that kind of thing. It's like the developers double dipping, because it's like they got the people to buy it on PS4 like 9 years ago. It's like now you can buy it again on either PS5 Pro or whatever, or PC like the following year, something like that. It's like they can do that, and it's like no one's really gonna call them out on that, because it's like it's so far apart in how long you had to wait that people get nostalgia and they're like, oh, I want to play it again. But they put something in there like director's cut or remastered. It's like, like with the Horizon Forbidden West game, for example. It had all those PC visual enhancements and stuff. So it's like it's trying to entice people who either never played it to play it, or people who already played it to play it again on PC. Because I feel like with a lot of these Sony first-party games, I should say, like the Spider-Man games, the God of War games, the Horizon games, I feel like the people that actually like these games, the biggest fan base for these games are the people who are very much in the PlayStation ecosystem, not the other gamers that are typically playing games more broadly, in different genres and in different platforms. Like, and when I say that, I'm talking about people who play like League of Legends, or people who play mobile games like Genshin Impact, or live service games like Helldivers 2, or people who play PC games like Halo Infinite, or Forza, or some whatever, like whatever PC game we're talking about. They're not really that into the Sony first-party game ecosystem versus like someone who actually plays a lot of Sony first-person games. Those people are actually more likely to buy the game on PC just so they have it, just so they can play it, just give them an excuse to play it again. You know what I'm saying? Like, you'd be surprised. I mean, there's people who do that for like Final Fantasy. Like, I'm a fan of the Final Fantasy series, but I don't have every single release and re-release and remaster and remaster of every Final Fantasy game. I'm not that much of a diehard fan for Final Fantasy, but I do have like basically the pixel remasters on Steam. I've got those, and then I have like the older version on like PlayStation and stuff from way back on like PS3 and PS4. So same thing with like Final Fantasy IX, you know, like old games that are rumored to get remasters at some point. You started The Walking Dead today, a 12-year-old game. The Walking Dead? Oh, yeah. For some reason, when I hear Walking Dead, I keep thinking of the show. I never think of the game. I think of the show. That's weird. When a show actually overtakes the actual source material in popularity. That's crazy. All right, so we covered 50 series. We covered PlayStation. Let's talk about Black Myth Wukong. So this is an interesting game. This I don't know why I'm talking about this, but I want to say something about this. This game is so commercially successful, but for reasons that I think a lot of people don't understand. Because right now, the news overseas about this game is insane. Like, most people in the West probably thought, oh, this game, it's really cool. It looks really cool. The visual style is nice. The graphical fidelity is very high end. It requires very high end hardware to run this game and get the full visual experience. But that is not the reason why this game is so commercially successful, why it has sold 18 million copies. Does anybody, I'll ask the chat without me diving into this article yet, like, does anybody in the chat know why this game has sold 18 million copies? And now it has been confirmed that there's an expansion in development. Because for a single-player game from a relatively small studio based out of China, with no real name behind the company, they just went from zero to hero and sold like 18 million copies. It's a really China-friendly game. China? Yeah, it's China. It's because of China, guys. So the Chinese market is where I would say, I don't know what the ratio is. If I had to guess, I would say like 85 to 90% of all the sales for this game are from the Chinese market. So it really shows that the Chinese market is a force to be reckoned with when it comes to consumer spending power. If Genshin Impact is anything to go by in terms of like spending power of consumers and the gaming market, as a case study, this is a very interesting case study in itself to show the power of the Chinese consumer, or the Chinese gaming market, I should say. Like, I kid you not, there are people in China, there are literally hundreds, if not thousands, of gamers that literally they upgraded their PCs just to play this game. I kid you not, there are people in China who literally upgraded their PCs, or literally went out and bought a brand new PC to play this one game. Like, this one game. Let me put this into perspective. This is a game that convinced it, like, it somehow made it compulsory for somebody who would have like a 15-year-old computer, who they literally had a toaster for their computer or a potato for their computer. And they literally were compelled by Black Myth Wukong to go out and spend a lot of money on a computer just so they could play a $60 game. Like, they spent, like, this game made people spend literally like $1,000 plus so that they could play a $60 game. Think about that. Let that sink in. When was the last time in your life that you wanted to play a game so badly, but your computer couldn't run it well because it was either too old or was just slow or whatever, that the game literally forced you to spend money and upgrade your computer? Can anybody in the chat list a game that forced you, that made it mandatory, it compelled you to spend money to upgrade your computer or buy a console or whatever? I'm curious to know. I'm curious to know because the guys, this says a lot about this game. Like the fact that it compelled so many Chinese people in China to spend a lot of money. We're talking like hardware, guys, to put things into perspective, hardware sales of computer graphics cards in China are up 400%. Like in the first week of this game coming out, hardware sales in China were up 400%. And then the following week, it was down like 200%, and then it's kind of like fading out now. But this is insane. This is insane. And you know what was also way up, like 150% up in sales? PS5. Chinese people were buying PlayStation 5s. If they couldn't afford the PC, they were going out and buying PlayStation 5s. And PlayStation 5 isn't even popular in China. Like, the typical Chinese gamers don't play on consoles. Like, they literally play on PC, or they don't play on PC at all, and they just play mobile games on their phone. Like, that's the vast majority of the Chinese market. So the fact that this game forced people to buy PlayStation 5s because they couldn't afford like a $2,000 PC just to play this one game, like, think about that. Think about that. So let me see what people are saying here. I'm curious to know what game compelled you to upgrade your computer. Let's see. Is anybody listing anything? Cyberpunk 2077 compelled you to buy. I'm so sorry. Minecraft RTX. Minecraft RTX? Minecraft? Red Dead Redemption 2. Okay, yeah, that's a pretty good game. Flight Simulator 2020. Star Citizen. Yeah, Star Citizen's very hard to run, man. Star Citizen Hades. Star Citizen is like, that's, hey, I'm just gonna tell you for real. If someone's gonna play Star Citizen, here's my advice: get an X3D. X3Ds are like the only CPUs that are good at running Star Citizen. There are no others. Not even Zen 5 probably. Test Oblivion, you needed a GPU that could do... Are you talking about like... Oh, the Elder Scrolls. Okay, the Elder Scrolls Oblivion. Yeah, that's... Okay, yeah, that one was a good one. Yeah, I knew a couple of people, like back when Oblivion came out, I was okay running it at like a juddery 33 to like 40 FPS back in the day on my aging PC at the time, but a lot of people I know upgraded their PCs for Oblivion. Yeah, I remember that. Leave it to Chinese citizens to follow through. Morrowind needed a DirectX 8.1. Yeah, I never played Morrowind on PC. I never had a PC that was good enough to run Morrowind. I played a little bit of Morrowind on the original Xbox. Alan Wake 2 because it uses Unreal Engine 5. Kira is saying you went from the 12700 to the X3D for Valorant. Oh, you upgraded for Valorant. Okay. Really? Valorant's that hard to run? Interesting. You're still on Ryzen 5900? Yeah, it depends on the games that you use. Like if you play a lot of games that are... Like, okay, Hades mentioned Star Citizen. Star Citizen is probably the most CPU-bound game. Well, okay, not really. Well, okay. This is my opinion. So I have played a little bit of Star Citizen. What I will tell you guys, Star Citizen is the most multiplayer CPU bound game I have ever played. That is Star Citizen. Now for single player, that award goes to Dragon's Dogma 2. Dragon's Dogma 2 is the most CPU bound single player game on the planet. And it's got me a little bit concerned for Monster Hunter Wilds, because Monster Hunter Wilds is going to be running on the same exact engine, the RE engine. Yes, Dragon's Dogma 2 is so CPU bound. Basically, anybody who is on a CPU that's older than like Zen 4 is not going to have a good time on Dragon's Dogma 2. Like, even Zen 3 is bad. Like, okay, 5800X3D is okay. 5800X3D is okay on Dragon's Dogma 2, but literally everything older than that is bad. Like, wow. Like, Alder Lake is bad on Dragon's Dogma 2. Everything, man. Like, Intel's 14th gen is okay, but like I said earlier, if your CPU is older than Zen 4, meaning if your CPU is older than 2 years, because Zen 4 is 2 years old this month. Keep that in mind. I don't have a Zen 4 with me, do I? Oh yeah, here we go. Zen 4, 7950X. This thing debuted, I think it was like September 26th of 2022. So if your CPU is older than this, Dragon's Dogma 2 runs like trash. Like, this is okay. 13th gen is okay. 14th gen is okay. X3D is fine. I mean, maybe Zen 3 X3D is okay. But, like, anything older than that, no. Go look at my reviews. Because I review Dragon's Dogma 2. I benchmark Dragon's Dogma 2 in the heaviest area in the game. Vernworth. Like, if you go look at other reviewers that benchmarked Dragon's Dogma 2, they were running their character around in the grass field outside. They're not gonna see the insane CPU bottleneck unless they go into Vernworth in the middle of the day when all the NPCs are walking around and all the timed events are pinging the cores constantly. Like, then you're gonna see the CPU bound scenario. Dragon's Dogma 2, well, okay, that's a different story. That's a different story. That has nothing to do with a CPU bound. That's incompetency on either Intel or I don't know even know who to blame. Capcom? Is it Capcom or is it Intel's fault? Or both, I don't know. Hopefully, by the time Monster Hunter, yeah, I think so. I think it will be out around that time. Well, okay, here's what I think is going to happen. Zen 5 X3D is probably going to come out either... If it comes out this year, it would be in December. So just to put things into perspective, if we get Zen 5 X3D at all this year, it will be at the end of this year. Otherwise, it'll probably come out next year. Like sometime in Q1 of next year. So think February or March... Probably February, if I had to guess, for X3D. But right now, for Monster Hunter Wilds, because Monster Hunter Wilds is really the only game that I'm interested in for next year. Unless From Software releases some new game, which they should release a game next year based off of their roadmap, but I don't know what it is. It's rumored to come out in March. Capcom typically releases their big game for the year in March. Every year. So think about like Resident Evil 4 Remake, Resident Evil Village, what was the other game that came out? Dragon's Dogma 2 was this year. Dragon's Dogma 2 was March of this year. So, and like Resident Evil 4 Remake was March of last year. So it's like Capcom typically releases very reliably. You can predict with high accuracy when Capcom will launch their big, major blockbuster game. Like, I know last year they also did Street Fighter 6. That was like June of last year. But that's a big game, but it's very much a niche audience. Not everybody plays fighting games. So, and I think they also released that to kind of align with EVO's time frame as well. So that's another reason why that would not be a March release. But they did Resident Evil in March last year, and then they did Dragon's Dogma this year in March. So I think next March, we're going to get Monster Hunter Wilds. And it was pretty clear from what they showed at Gamescom that that game is already done. So it's going to be hard to run. It's going to be very hard to run because the people at Gamescom were commenting. I think they were all using PS5. That was at the show. And they were saying like there was a lot of FPS drops. And when I heard them say, oh, there was FPS drops, I was like, oh, man. Monster Hunter Wilds is going to be hard to run. I don't think it's going to be as terrible as Dragon's Dogma 2 because I don't think it has as many NPCs on the field. But I could be wrong because instead of it being NPC humans, it could just be NPC animals that you have to hunt. So it's like, it could still run just as bad as Dragon's Dogma. I think if it runs as bad as Dragon's Dogma, that will be extremely disappointing because I think Monster Hunter has a much higher player base compared to Dragon's Dogma. What do I think about the Ryzen 7900 non-X3D? That's pretty much like a 9900X, or no, it's not actually. Is because that's that's wrong. That is an interesting CPU because it uses less power than the previous generation while performing about 13% faster at like what 40% less power. So it's interesting. I do think that a lot of people overlook certain CPUs. Like, no one talks about the 7900, like you said, the 9900X, and they don't really talk about the Ryzen 5. Like Ryzen 5 7600, Ryzen 5 9600X, like no one really talks about those. And I think those could be good value for someone who's on a very tight budget. Although Ryzen 5s don't come with the 2 free games right now. What do I think? Oh, where is DDR5 6000 still the sweet spot for Zen 5? I think you can do a little bit better now with a newer memory controller. I think a lot of them can do either 6200 or 6400. But I still kind of think if you want to run 8000, run 8000. I actually recommend, so if you're on Ryzen 5 or Ryzen 7, like if you're thinking about getting a 9600X or a 9700X, I actually recommend you try to aim for 8000. Like aim for the magic memory. Meaning try to get something like this. The G-Skill 8000 kit that I've used. Because if you're going to do like 48 gigs of memory, try to do 8000 and you're on a single CCD. I think that will be the best performance. Otherwise, if you're on X3D, then you don't really have to run the higher speed memory, but you still can. I mean, it's still going to help. It helps with 1% lows, 0.1% lows, and you're about 4 to 5% faster on the 1% based off of my own testing. I have a whole video showing this. And then you're about like 2 to 3% faster depending on the game on your average FPS if you're on 8000 versus like 6000. So, and that's 8000 gear 2 versus 6000 gear 1. So, and that's X3D. Like I do plan to test 6000 versus 8000 on a Zen 5, like on a 9700X, for example. So I do plan to do that test because I want to see if the not having X3D does a non-X3D Zen 5 CPU. I mean, this could also apply to Zen 4. Do they benefit more from the higher speed memory than the X3D? Because the only one that I've tested, at 8,000 versus 6,000 was X3D. Like, I've done tests with X3D, and the average uplift is 2%. So people are like, oh, 2%, that's like nothing. Like, that's not even worth doing. Yeah, I would tend to agree. The minimums are about 4% better. So you're 1% low, you're 0.1% low. There is an improvement running at higher speed memory on an X3D CPU. So I don't know if non-X3D benefits more or if it's the same. It's either going to be the same or it's going to be a little bit more, if I had to guess. But I have to test it, and then I'll make a video about it. But at this point, I'm kind of waiting to see what happens with the X870E, because I really, really want to see if these newer motherboards improve the memory performance for Zen 5. Because right now, to me, it feels like we're limited by the motherboard. Like, I feel like there's something limiting the ability with the memory here. And it's definitely not the IMC on the CPU. Because if you're doing 2 sticks of memory on an 8-layer PCB, you're able to run 8,000 no problem. But I want to know what happens if I take a newer X870E board, for example, and we try to run 4 sticks of memory. Can we reliably do 4 sticks of memory at, say, 6,000 megatransfers? Or if we're on single rank DIMMs, like, for example, my 48 gig kit here, this is 2x24, like, can I run 4 of these at like 6,400 or even 8,000 on a new X870E? Now, I'm hoping there's a possibility. I don't expect it, but who knows, maybe. So if you're trying to do a Hackintosh, it depends on the version of iOS or not iOS. Is it Mac OS? It depends on what version you want to run, because you can do a Hackintosh with the Radeon card. You just need to make sure that you're basically trying to build like an iMac or something. I forget what they called their desktop platform. But it may work. You may be able to get it to work if you have the right image, like the OS for Mac. All right, let's look at hold on. What do I want to do here? Oh, yeah, we're talking about motherboards now, since we've kind of moved over. So MSI unveils its flagship MEG. MSI was the last one. I should add, MSI was the very last one to unveil their upcoming AI-powered, I don't know what this means, AI deal innovation. That's how they're marketing it. But basically, they were the very last one to unveil their X870E and X870 motherboards. So there's 4 of them that they showed off. They recently did a live stream event. For those of you that are following MSI, if you're like an MSI fan and you use a lot of MSI hardware, you probably are someone who tunes into the MSI Insider live stream, and they show a lot of their products on those live streams. So they did show, in person, they were showing the Carbon Wi-Fi, the Tomahawk, and I think this one is the X870- or the Pro X870-P Wi-Fi. And they had some slides and they had like some video clips that talked about the Godlike. Yeah, they did not show the Ace, which was very surprising. And people were asking them about that, and all they said was these were the ones that they were going to launch with initially, but they were going to do a rollout over time, meaning they would introduce more motherboards over the lifespan of the chipset socket, or the chipset generation. So in this case, X870 and X870E. So there could be an Ace, but when I saw the Godlike, so this is the Godlike here on the right. When I saw this, my first thought was, man, it looks like they took the aesthetics from the Ace and they fused it with the Godlike. But the Godlike is the most interesting one. In fact, I want to kind of look at this a little bit. So let's skip to their live stream where they talk about the Godlike. But they show...
And also 27 watt power delivery on the front USB.
This is that one that he's showing right there is the Carbon Wi-Fi. That's the Carbon Wi-Fi. So, but I want them to, let's skip, yeah, they're going to go to this part.
Seen before.
There we go, the Godlike.
And this is, of course, also...
we even didn't see the real working sample.
No.
But Ruud saw. He said, oh, Godlike looks great. And if Ruud says that, then it's usually
impressive.
Yeah.
Yeah.
So this is, of course, also X870E. So also the dual chipset solution. Has a bunch of RGB on there. Looks really nice, I think. This is also an extended ATX motherboard. So it's bigger than the motherboards that we've just shown you. If you want to use a motherboard like this, make sure your case is also compatible with it, because it's quite a bit bigger and wider.
It's
I want them to get to the part where they show the actual, okay, like
filled with tons of ports.
So right here,
connectors. So we talk about Type A.
So right here on the back, they basically are trying to do that thing that they did with the concept, where they showed off this. I think Asus originally showed like a BTF form factor, and then I think MSI did one, and I think somebody else, maybe ASRock or Gigabyte, did another one. So when they showed, if you guys remember, I think it was Computex, MSI showed off a motherboard that had only USB-C on the back. You guys remember that? Which was very gimmicky, because the reality is a lot of people still need USB-A. But this is kind of like they took some of that idea where they put a lot of USB-C on the back, but there's still a lot of USB-A. So that's a lot of USB-C for one thing. And the other thing too is these top two ones here, these are the USB 4 ports. So these are 40 gigabit USB 4. Both of them support DisplayPort alt mode, so you can run, so like for example, if you're not going to use a graphics card, like you're trying to build some kind of production system that doesn't actually use a GPU, but you still need the integrated graphics, then you could drive at minimum, you could do 2 monitors off of these USB-C ports. But because they support DisplayPort alt mode and they use essentially Thunderbolt 3 technology, you could actually daisy chain the DisplayPort monitor. So you could actually run a lot of monitors, I think like up to like 6 monitors or something, off of these 2 ports. So that's a lot of monitors off of the integrated graphics on the Ryzen CPU. So on top of that, all these other USB-C are all 10 gig. Then every single one of the USB Type A are all 10 gig. So it's like, at minimum, the speed of every USB port is 10 gig. And then you have these 40 gig ports up here, these top 2 ones. And then it has the Flash BIOS button, the Clear CMOS button, and the Smart button, just like we saw on the Ace and the Godlike from the previous generation. And then on top of that, it has 10 gigabit LAN and 5 gig LAN. So it has dual NIC, but one is 10 gig and one is 5 gig. So it's pretty insane. Then you got Wi-Fi 7 on here, but every single one of these X870E motherboards are Wi-Fi 7. That's pretty much standard at this point. And then you have SPDIF, so optical out, and then they have the analog audio stuff here. So this is a really nice rear I/O on this board. So already the Godlike is more impressive than the previous generation Godlike.
10 gigabit per second, Type C, up to 40 gigabit per second. Of course, this one will have Wi-Fi 7.
I may have to correct myself, but I need to double check, because it does show on the I/O that it carries a DisplayPort signal.
Oh yeah, they didn't even know that their own product can do multi-monitors off of those DisplayPort alt mode ports. So we're gonna skip ahead because these guys don't know their own product.
First thing I noticed here compared to our previous generation is the number of USB Type-C ports. It's
a lot of
USB-C.
USB-C. All right, let's.
Everything, because of course you also have USB-C front header.
What I like is, it looks like this Dragon is on top of it, and not.
So up until now, the most interesting motherboard that I thought was probably the front runner in terms of like which one I thought was the best motherboard out of these X870Es was Asus's Crosshair Hero. So X870E Crosshair Hero, I thought that was the most impressive motherboard out of all the motherboards that were shown. That one I thought was more impressive than Gigabyte's AORUS Master. And we're going to take a look at the Taichi, but so far I don't know too much about the Taichi at this point, but so far, until I saw the Godlike, I thought the Hero was the most interesting motherboard. But now I kind of think the Godlike might actually be rivaling the Crosshair Hero.
Not only with RGB, but also without RGB, a little bit slower of course. It looks really awesome.
How can you run multiple monitors on AMD APUs? You have to have a motherboard that has enough outputs for you to connect those monitors.
And this is not a marketing video. This is just, we ask a colleague in SU, hey, can you shoot some video? That's why you see the cable and, is that somebody's sock in the back? I don't know. Oh, you didn't see that over there.
I mostly see the fingerprint, but that's your laptop screen because
yeah,
I don't see it on
and the green sticker over there next to the CPU socket.
Yeah, so
that means it actually is working sample.
It's a quality check, okay, indeed.
Yeah. Okay, guys.
Yeah.
We need to.
Yeah, those are fingerprints.
I need them to like move on.
Nope, still there.
Still there. With support for Dynamic Dashboard 3.
Okay, so the thing is, the module, that thing on the right side of the board actually is removable. And then there you can see the RTC battery. And then there's a bunch of like, this looks like there's a PCIe 8-pin connector for, or is that a 6-pin? That's an 8-pin PCIe connector for auxiliary power for the PCIe slots. Then there's a 24-pin. Everything is right-angled. I'm not a big fan of right-angled connectors because then you got to make sure that your case can fit this sort of setup. This is also an EATX motherboard, so it is a much wider motherboard than the standard form factor.
You can take it off and reinstall it. Magnetic system as well. And this is actually a very interesting module.
So normally I consider these kind of gimmicky motherboards because this has like what I see at first glance, I'm like, okay, these are a bunch of gimmicks. However, the thing is, a lot of the connectors are actually on what they're calling this easy bridge. So like, for example, they have your RGB headers, the MSI proprietary JFP1 or something is on there. So some of those connectors are actually like, you have to use this easy bridge if you're going to go for like a certain RGB setup, because otherwise you can't like remove this or not use this and then have it work because it just doesn't have the headers on the board otherwise.
Here you see the module separately.
Yeah, so
and this module also has physical buttons on it. I bet one of those buttons is probably for the GPU disconnect.
over here on the bottom side, you also have the, well, we talk about that later, the Easy PCI Express release for your GPU.
I love it that you point to your screen as if
damn.
the viewers can actually see that.
Yeah, see, look at that, look at that. JFP1, JFP2, the bridge connector, temperature sensor 2, temperature sensor 1, tuning controller, whatever that is, something, the JAF2 connector, a USB 2.0 header is actually on this bridge. So I think that's for front panel USB 2. So you kind of have to use this bridge as part of the motherboard. So it's not, at first I thought, okay, this thing looks like a gimmick, but it actually has some of the mandatory connectors like JFP1, JFP2, and the USB 2 header is actually on this thing. And then in addition to that, it has the labels for the other connectors that are on the physical motherboard.
That was very helpful, Eric. Very helpful.
I did. Okay, maybe I stop the video here. One moment. Video, stop.
Oh wait, what?
I want to show this. So,
Oh, the pump header.
the side of the.
Yeah. Okay, let's skip past that.
Here you can see it on the motherboard.
All right, so here it's kind of out of focus, but on the left here, it looks like there's two USB 3.0 headers, and then you can see two USB-C or USB 3.2 headers. One is a 10 gig USB-C. The second one is a USB 20 or USB-C 20 gig with 60 watt power delivery. And I think you have to use this PCIe connector, this PCIe power plug, if you want to take advantage of that high-speed charging power delivery to the front panel of the case. Assuming you have a case that supports 60 watt power delivery over USB-C. So this is definitely a very high-end motherboard because it has stuff like this on it. Typically, if you wanted something like this, you had to buy a motherboard that had an add-in card, or you had to buy an add-in card separately, like, for example, a Thunderbolt 4 add-in card. I have videos showing how to add those things to these type of motherboards previously. But it's nice to see this is included in the motherboard, so you don't have to buy a separate add-in card if you're someone who wanted this sort of functionality.
The bottom headers is also on the Easy Bridge module. So there you get, all are angled, of course, so 24-pin power connector. You have, that's the 6+2 pin, right?
This one.
Oh, that's the power delivery one.
Yeah. That's for the USB.
Yeah, that's for that USB.
So for Type C front delivery port.
All right, let's move on here. Oh,
and
okay.
This is basically a fan hub.
Oh, okay. So the Godlike includes a fan hub.
Well, both a fan hub and an RGB hub, actually. There are ports on two sides, so it has multiple 4-pin PWM fan connectors, and it has multiple 3-pin addressable RGB connectors. And this one is actually connected to the module that we just saw. It comes, there you see them connected to each other.
Oh, look. Okay. Okay, that's interesting. So it's funny seeing this because it's like, it has a ribbon cable. When I first look at this, I'm like, whoa, it actually comes with a fan header and a ribbon cable that connects to this easy bridge. So yeah, this motherboard, the Godlike, this time around has a lot of what I call gimmicks. Because this is all optional stuff that's going to drive the cost of this motherboard like way up. This is most likely going to be the most expensive X870E motherboard because it includes all this extra stuff.
And the one on the right, so the hub, that one but I think it comes with double-sided tape, right? So you can stick it to the back of your motherboard tray.
After this, we will talk. We have more detailed slides.
Can you see the tape?
Nah.
You play a 1080p and you upgrade it from a 1070.
Or your fans, your RGB.
Yeah, the 4060 will be fine at that resolution for a while, but like Matt was saying, the VRAM is going to become the limiting factor pretty quick on that GPU.
We had so many videos, we need to make a selection. So this is the Easy Link. So you have the Easy Bridge, which basically is your dashboard, where it's included, and then you have the Easy Hub, which you can put in your case, where you connect all the cables. And you can hide them, basically, because that's the same concept like what we have on the...
I mean, that GPU will be okay for a while. Like, you should be good.
So
you can.
Fans,
so if you're just going to play a 1080p, you can probably skip the entire 50 series and AMD's stuff, unless there's like a insanely good value GPU that comes out in the price range of the 60 class sometime next year.
Two RGB fans, 5-volt, one RGB fan, and full water flow connector.
But an example of a GPU that would have been better than that 4060 would have been the 7600 XT The 7600 XT would have been kind of the same price, but it would have come with 16 gigabytes of VRAM.
Horizon is asking, is this board as wide as the C791 or the X671? I don't know, to be honest. We haven't had the physical sample here yet.
Check. I have probably.
Yeah, what was weird was they had the other 3 motherboards to show off, but they didn't actually have the Godlike on hand.
Because usually around... So here you see...
Oh, check it out, check it out.
Demonstration would than what I did.
He plugs it in,
Definitely.
he presses a button,
And he doesn't pick it up with the graphics card.
he presses the button,
How good it was.
It was definitely...
and then it comes right
but
out.
still, you shouldn't do it like that.
This is very nice to see. It seems like every motherboard brand now has the quick disconnect functionality on their motherboards. So it doesn't matter now if you have ASUS, MSI, ASRock, or Gigabyte. All of them now have a way to easily remove the graphics card. So that is very nice to see.
But
I think MSI was the very last one to get this ability.
See that the Easy PCI Express release button is also integrated into that module. This is the same system like you saw on Carbon, Easy M.2 Shield Frozr.
There's the Gen 5
It also
SSD.
comes with the second generation Easy M.2 clip.
And it's
Almost
there's
better
no
than
there's
the
no
one.
more screws. It's all like toolless. That's really nice. It has RGB on the heatsink. Okay, so he's showing it off now. Oh, here comes the second
now
big
our colleague-
heatsink.
Our colleague takes all
Well,
of them off, so
3
you can see
more.
all
So you got
the
4,
M.2 slots on the motherboard.
and then we take
5
this
on the
thing up.
motherboard.
Oh,
Yeah,
5
the Godlike also comes
M.2
with an
drives.
additional card for 2
So this
more.
motherboard can support 5 M.2
That's
drives.
also this.
Now, what I will say about that is 1, 2, 3, 4, 5. That means that there is going to be, unfortunately, there's going to be some lane sharing for these M.2s because the chipset doesn't have enough lanes to support 5 M.2 drives. It cannot physically do that without borrowing lanes from the graphics card slot or the CPU lanes. So it's nice to see 5 M.2 drives. So it's like if you're someone who really, really needs to fill up all 5 M.2 slots, you have the ability to do that. But keep in mind that there's going to be some sort of compromise in terms of the lane availability. So it's like, I'm guessing, for example, this bottom M.2 right here shares bandwidth with this bottom PCIe slot. So this PCIe slot looks like it's an open slot that's cut short. So this is an X4. Most likely this is an X4 PCIe Gen 4. It could be PCIe Gen 5, but it's probably PCIe Gen 4. It's either 4 or 5. But I'm willing to bet that this is probably Gen 4, and this M.2 drive that's right next to it, probably both of these are wired to a switch, and you either choose one or the other. Meaning, if you have something plugged in to the PCIe slot, you can't use this 5th M.2 drive. Otherwise, if you want to use the drive slot, then you can't use the PCIe slot. So that's just because of the way these things look. I'm assuming that there's some kind of lane sharing going on here, because otherwise I can't see them pulling this off, because like this is what, 4, 8, 12, 16, 20. This is 20 lanes of NVMe. 20 lanes of NVMe equals the 20 out of the 24 CPU lanes. That includes the graphics card slot. So yeah, I don't think this is, yeah, there's going to be some kind of compromise is what I'm saying here with this motherboard in terms of, like, if you want to populate all the M.2s, just know that there's something that you can't use. It's probably this slot or something like that.
Card for 2 more.
Well, that's after
This would be a very interesting motherboard to derive the block diagram, just like I did for the Crosshair Hero.
How's that good?
Because that motherboard from
that's a
ASUS
logic
also
interpretation.
had
And I
5
completely
M.2
No,
slots.
the logic is still there.
But we already got the question, how many PCIe 5 NVMe? Well, actually, 2 on the board itself
Yeah.
are Gen 5, and both of them on the separate card are Gen 5.
It can't take the SATA ports. And the reason why it can't take the SATA ports, because the SATA ports are either dedicated to SATA or they're dedicated to PCI Gen 3. And they said, one of these two guys said earlier, I don't know if you guys heard him say it, but he said that two of the M.2s are Gen 5. And then he said the remaining 3 are Gen 4. The moment he said that those other 3 are Gen 4, I immediately thought, okay, so that means they're not going to take, there's no compromise on the SATA, because SATA is only going to take PCIe 3 lanes.
So you get
SATA will never take PCIe 4 lanes.
up to 4 M.2 Gen 5 slots.
So I believe the top 2 are
Oh, okay. You know what he just said? He just said that you can do 4 Gen 5 and 3 Gen 4. So I think what that means is that it's going to be 1, 2, and then this second PCIe slot is probably going to be an X8 slot that has the MSI expander card, which can add an additional 2 Gen 5 drives in the PCIe slot. So that's how you get 4 drives, 1, 2, 3, 4, and then you get 3 additional Gen 4 drives. That means the Godlike supports, out of the box, the Godlike supports 7 M.2 drives, 4 Gen 5 and 3 Gen 4. So this motherboard is currently like the highest end, like this is like the highest end motherboard I've seen on the consumer desktop, because what I can tell you guys right now, I'm currently myself, like on my Threadripper system, I currently run 7 M.2 drives on a Threadripper system. And the fact that this Godlike can match the number of drives that I am running on my Threadripper system is very impressive. That's very impressive.
Gen 5.
Yeah.
So this one and this one, these 3 are Gen 4.
Okay,
Don't
see,
be
Gen 4.
mistaken, this is not an M.2. It looks like it.
But it's not.
It's not. And then we have, well, oh, that's maybe later. So it's not logical.
Good structure, yeah?
Okay, these guys are like jokers,
You can do the
man,
giveaway,
with the
but
way they
Battlemage will help
present.
you participate.
Yeah, you distract them.
Okay. There, in front of... Oh, now it's here.
No, they're gonna do their little giveaway. No, these guys go way off topic because he messed up the
Wait,
slides.
Bonus.
Coming down.
Alright, hold on, let's
Come
go.
off the
Yeah, very low.
I mean-
Down the motherboard.
pads. Yeah, the wavy. Anyway,
You see the different fins.
Oh, there's
And
the
that is to
heatsink for the
increase
I/O
surface
cover.
area for better heat.
It's the
dissipation.
VRM and the I/O cover.
so below this heatsink you also have the USB cooling. In this one it's low design, similar like what we have in Carbon, because over there you have the USB 4 ports. Oh, sorry, the what is it? USB Type A 10 gig ports.
Yeah.
8, I believe, right?
Yes.
No,
Now there are 6 on that.
6. He's a little bit angled. This is not a.
Okay, look at this insane VRM.
This is just to show you guys. how
Look
it
at
works.
how many power stages that thing has.
But here you see.
Look
the
how many
VRM.
chokes are on there.
Huge VRM.
Look at this. It's a huge VRM.
Yeah, if you-
24.
Yeah, 24 110 amp smart
24 110 amp.
stations. If you're
Phases.
curious about the separate PCB with the 6 Type A ports and the 3 buttons, then also check out the Gamescom stream, because we also could.
And it even has a secondary daughter board over here for the USB A ports up here.
Completely took that apart on the Carbon, which works in a similar way.
I pray to the godlike.
Oh, and then also, you can barely see it, but right there, I think there was a heatsink that they removed. This right here, this chip is most likely the USB 4, the ASM4242 from ASMedia for the 40 gigabit USB. That's supposed to have a heatsink on it. So most likely, the VRM cooler the FinArray has a heatsink for the USB 4 controller. Because think about that. That controller handles dual 40 gig USB-C. That is a lot of bandwidth. So that thing definitely has to have a heatsink on it.
How many chokes are on that board? In total, 26. Because there are 26.
No, there are more. For
the VRM.
For the phases.
Yeah, so basically every power stage has a choke, and then you have 24 for the V-core and 2 additional ones.
Wow.
And perhaps one for the IGP.
That is so overkill for Zen 5. This is like such overkill for this type of CPU. It's crazy.
Not for the iGPU, I believe for the clock gen. It's set.
You don't have a separate... I don't think you have a separate MOSFET for it.
Okay.
He did mention just now that it has an external clock generator. So if you were somebody who was wanting to overclock, this is definitely going to be an overclocker's motherboard in terms of it has the external E-clock, so you can do like E-clock 1, E-clock 2, just like on the Hero.
Pretty sure it doesn't need a separate MOSFET.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's 1 banana. It's 2 bananas, so 24. Okay, 13.
You want
14,
the Gigabyte
15,
X870E AORUS Pro
16,
Ice?
17, 18, 19, 20, 21, 22, 23, 24.
ASRock may also have a white motherboard.
So that's what I
So
said.
it's 24 plus 1 plus 1?
No, I think it's 24 plus 2.
Yeah, that's the same. Anyway, we need to figure out how the IGPU works.
Whether or not it has the...
See, the thing is, this is one of those motherboards that if you actually do get this motherboard, like, you don't need any other motherboard until you basically go to another socket. Like, this is the sort of motherboard that if you get this, it's like, okay, you can put Zen 5 in here, and then you can put Zen 6 in there, or you can put Zen 6 X3D or whatever. And it's like, it's good for like all the rest of whatever is going to come down the pipe in terms of AM5 CPUs.
IGPU power.
Yeah. Maybe Ruud is still awake.
Is he? It's midnight there.
Yeah. And he had a jet lag. And this is...
Or he's partying now.
Yeah, no. He was going out for dinner and then I...
And then after party.
Yeah. And this is with everything removed. Not everything, but with the M.2 heatsinks as well. You see, now we have the M.2 heatsinks removed. We can talk about 5 M.2 SSDs over there. But we have additional. We have 2 additional PCI Express Gen 5.
Good story, good structure. I
Good
like
structure,
it.
yeah, good. And there was one question like 1 hour ago in the chat, and I remembered it. And I don't know the answer, maybe you know. If you add in the PCI Express card, will your GPU be cut in half? Like by PCI Express by 8?
Yes.
Yes, it will.
The lane division will be 8 by 8.
Yes, it will.
This is the
Because of this thing. So I was expecting that they would include this because they were talking about this earlier. But somebody in their chat asked them just now, if you plug something into the second PCIe slot, will the GPU lanes be cut in half? And the answer is yes. Because that's how standard consumer motherboards always work. Like, if you don't want that, you have to get Threadripper. I mean, that's how it's always been for consumer desktop platforms. That's why even though this Godlike is marketed as like a super high-end motherboard, at the end of the day, it's still a mainstream platform. It is not a true HEDT. It is not a true high-end desktop. The only true high-end desktops are Threadrippers.
M.2 expander card. The slider version we already showed you on...
But this is actually pretty cool that it includes this. So basically, man, the Godlike includes the ability to just buy the motherboard, and then you can already do like 7 M.2 drives just right out of the box. You put 2 M.2s on this thing, and then you would have like and look, they even have the easy slide. Easy slide hot swapping. That is cool. I like this. This is way better than having to like remove 8 screws on this thing and then pull the heatsink off and hope you don't tear the thermal pads. And you know, then put the M.2s in there and then put it back on there and put all the screws in there. No, like this easy slide thing is awesome. With the tray. This is like, this almost looks slick. Like it's like a mini version of an actual server.
Computex.
And I like that it's one slot only. It's single slot. It's not that terrible like double slot thing that nobody needs for M.2s.
One slot thin, you can add in, as you can see at the bottom, 2 hot swappable M.2 slots. And yeah, it's a little bit like the GPU. You click on it and they pop out.
Yeah.
And there is a fan, of course. There's always a fan. I mean, some people say you need to be wide a fan, but it's it's PCI Express Gen 5.
Gen 5, yeah. Well, you've seen Gen 5 SSDs. They usually have pretty big coolers on them. That's for a reason, because they produce quite a bit more heat than we saw with previous PCI Express generation SSDs.
Yeah, this is a Gen 5 card too. Yeah.
On our previous card,
Man, this sort of thing, it's like making me realize I really want to know like what is the block diagram going to be like for this, because it's got 12 lanes of Gen 4, 24 lanes of Gen 5, and 8 lanes of Gen 3. How is it going to be able to house all that stuff?
we had a dip switch where you could switch the fan off. I'm not 100% sure if that's also in this one, because we don't have a
I think we're going to have to try to
yet.
derive the block diagram on the
But then in
Godlike,
case
because
you
this
wanna
is
use,
an
for
insane
example, a slower
motherboard.
SSD that doesn't produce as much heat, then you may be able to use it passively as well.
So Mike's Unboxing Reviews and How To, probably has his own YouTube channel, is asking, is MSI abandoning the ATX Project Zero boards on AM5? No, we're not. Like what Mike explained, hey, two mics. What Mike explained earlier, this is our Wave 1 products, and we already have more products on the roadmap. So it's
Okay, so someone else asked him, the question was, are these the only X870 motherboards, or are there going to be more? And as he's saying, there's going to be more. I mean, these are the ones that are the first wave.
just a matter of time.
But yeah, this is just our first wave of 800 series motherboards on AM5. So you can definitely expect more models in the future, and perhaps also Project Zero ones.
Yeah, so this is Godlike, tons of features, looks beautiful.
And 10-layer PCB, whereas the other one are 8
Oh
layer.
wait, what? This is a 10-layer PCB.
We're shipping one, right? So
Yeah,
it's a matter of time
should have
before
one,
we
I
can
think.
show you.
He just said right up there, server grade 10-layer PCB. That's good. That right there means that this probably can do better DDR5. Like 4 sticks of memory DDR5 will probably run better on this motherboard because it's a 10-layer PCB. 10-layer PCB. Now I gotta go back and look at the ASUS one, because I think the ASUS one was an 8-layer.
Yeah.
If we have the time, to plan it in. So yeah, this is some photos of Godlike.
You see the big backplate as well.
And they removed the green sticker.
It even has a backplate on the backside.
No green sticker on
That's
this one.
that's the difference between marketing photos. They always look a little bit better,
Yeah.
but it doesn't matter. I mean,
PG Ace.
Okay, so I want to try to draw the block diagram on this thing because the this is going to be an interesting motherboard. So let's see. So they said there's 5 M.2s. So that means there's going to be a switch here. The first thing that I can think of is there's going to be a switch, and you've got the graphics card slot, and then you have the X8 slot. But I'm wondering if there's some other thing that, well, anyway, let's keep going. So then you have he said that there are 2 Gen 5 drives. So there's 2 Gen 5 drives. And then we have the first chipset. And then there's the second chipset, which I kind of think I should have drawn this a little bit more like this, but anyway. So there's another chipset down here. Have to put these closer together because I kind of drew this weird. So anyway, this is here, and then you have the PCI 4, then you have the PCI 4, and then you have PCI 3, and then like RAM and stuff is on this side. So we've got AM5. We have the, what do we want to call this? Well, this is the chipset and the second chipset. So he said that there's an M.2. But see, the weird thing here is there's two Gen 5. This is 24 lanes total. This one is PCIe 4.0x4. This is PCIe 4.0 x8. This is PCIe 3.0/SATA x4, and then this is like the same thing down here. So we have PCIe 3.0/SATA x4. So this is all that is on the motherboard. Like, this is what you have to work with. So it's like there's no way to add more lanes. So unless they're doing some kind of weird like PLX chip that splits PCIe 5 lanes into like PCIe Gen 4 lanes, I don't think they're doing that. So the one thing though is he said they had like two M.2s that are Gen 5. So down here, this is probably the... This is where it gets really confusing because they have three Gen 4. They have three Gen 4 he said 3 Gen 4 M.2. But the thing is, if you guys remember, there was a switch at the bottom. Or no, there was an open X4, and then there was like another. So I'm guessing down here there's like a switch, and then the options are you get either an X4 or you get an M.2. So this is gonna be PCIe X4 slot or M.2. It's one or the other. There's sharing going on. And then there's another M.2. And there's like another M.2. So the problem that we're running into is, first of all, where is the ASM4242 going to go? Because that is for the USB 4. That requires, based on, unless they're not following ASMedia's spec, ASMedia says that the ASM4242 needs 4 lanes of PCIe Gen 4. So unless they're doing something weird where they're actually running it off of PCIe Gen 3, which technically they could do that, but I think the bi-directional bandwidth will be limited. So if they do, like for example, let's just say ASM 4242, this is basically USB 4. This is where the external monitors are. That's going to take 4 lanes. So then the question is, what about SATA? Like, what about the legacy SATA, the 10 gig, the Wi-Fi 7? You see what I'm saying? Like, this is a very interesting motherboard to try to piece together and figure out, like, what goes where. Because, okay, Wi-Fi 7 is going to be, like, one thing. 10 gig is, like, 2 lanes. So this is going to take 2 lanes. The Wi-Fi 7 technically should also probably be 2 lanes, but I guess you can get away with running that on 1 lane. And then that leaves 1 lane for 5 gig. So the problem is they got dual NIC. They got 5 gig. So, okay, does this motherboard have like no SATA? Like, how is it supposed to work? Does this motherboard literally have no SATA? That was the one thing that wasn't shown. Because this could probably work with no SATA. With no legacy SATA, they could pull this off. This is going to be the GPU. So this is basically like X16. You got 16 lanes here, but it splits. So it's like, if both of these are on, it's like X8, X8. So it's like that, or it's full it's full bandwidth to the GPU slot, or if it's gonna, meaning like if this is active by itself, you got 16 lanes, full bandwidth. Otherwise, if you plug in the expander card or anything into the second PCIe slot, it down regulates this to X8. So basically, both of them run at X8. So that's how that always works. But yeah, this is a really interesting motherboard because what this shows is if you remove SATA from the whole thing and you just don't have any legacy SATA, which is kind of weird, but if like the fact that you can do 7 M.2 drives, because it's like you have what? You have M.2 here plus another M.2. So it's like we got 1, 2, 3, 4 Gen 5 M.2 drives plus 1, 2, 3 Gen 4. That's 7 M.2s. 7 M.2s. So I guess the question is SATA actually needed? I don't know. I didn't see any SATA ports on the board, so I'm assuming there's like either no SATA or there's only going to be like 1 or 2 SATA ports max. And if there is, I don't even know how they're doing that. Because it's like, where is this supposed to go? Like, if they're going to put SATA, like, where is this? Like, they can't compromise USB 4 for, like, 1 M.2. You see what I'm saying? So it's like, I'm very confused. Or maybe this is, like, over here, and this is actually over there, and it's a Gen 3, and they didn't say that. But, yeah, I don't know. This is a very interesting motherboard. So for those that are tuning in, we're trying to derive the block diagram for the X870 Godlike. This is the MSI MEG X870E Godlike. Oh, there's 2 SATA ports. Okay, so if there's 2 SATA ports, then that's weird. Okay, so if there's 2, that means this is here. And then that means this has to go there. And then that means, okay, so if there's 2, then okay, let's say there's 2. So here's what they could do. They could run an ASM. They could put in like an ASM splitter. So they could do both SATA. They could do both SATA off of one. Actually, no, I don't see them doing that. I think what they're gonna do. If you okay, you said there's 2 SATA. Let's assume there's 2 SATA. Then, what does that mean? Then they can do. Okay, they can do SATA 1 and 2. Each have their own lane, which means they can both support like RAID 0, RAID 1, RAID 10, etc. RAID 5. Although I don't know if anyone's going to even bother doing that with 2 SATAs, but you could probably do RAID 0 if you wanted, but I don't think it's worth it. And then the remaining 2 lanes would be an M.2. I mean, they could do that. This would be an X2, an X1, and an X1. Like, they could, in theory, this could work. Like, it would be kind of lame because it would be like one of the M.2s would only be half speed of 3.0. Which, on the flip side, they could potentially make it one of those weird, you know, those backward compatible M.2s that can either be a SATA M.2, like a legacy SATA M.2, or an NVMe. They could do that with this. So it will be the slowest M.2 on the entire motherboard, but they could actually make this work. So that's technically something that they could do. Interesting motherboard, though. Probably the most interesting motherboard that I have seen in a while. So we're gonna put the round square around that. So that's probably how it's gonna work. or how it's going to look. Something like this, if I had to guess. So those guys, but the weird thing is those guys were saying that the 3 M.2s were Gen 4. So unless they're wrong, which I don't think they're wrong on that, which makes me very curious to know, like, how are they actually doing this? Because, I mean, if it was me, I feel like this is good. Like, this is good enough design. Unless somebody needs a lot of SATA, and I feel like there's people out there that they want, like, 8 SATA ports in 2024. And I'm thinking, like, have you ever heard of a NAS? So, like, do you really need that many SATA devices? Nobody that I know are still installing games on a hard drive. Like, I don't think anybody's really using hard drives for games. Maybe for, like, really old games. But most modern games require an SSD anyway. So, and the problem with SATA, like, even if you buy a SATA SSD SSDs at this point are kind of a waste of money because you're heavily bottlenecking the full potential of your flash memory because SATA is a bottleneck. So, yeah, I think SATA is definitely on the way out for the consumer market. It's definitely not a thing in laptops, I'll tell you that. Like, laptops have been on M.2 for many, many generations now. It's been like 6 years. But yeah, if this is what the block diagram is, this is actually a pretty good implementation. I would say this is a good one. If this is how it's actually set up. Because it means that what it shows is that you can still do, like, what, 1, 2, 3, 4, 5. You can still do 5 M.2 drives without stealing lanes from your graphics card. And if you want 2 more M.2s, you can borrow lanes from your graphics card. So I feel like that is a nice compromise, if this is in fact how the board is actually designed. But so far, I would say this is the best one that I've seen, by far. This one is a 10-layer PCB. So that right there means that this is definitely more high-end than pretty much every other X870E. But I would imagine this thing is going to be insanely expensive for a motherboard. Like, this motherboard is probably going to be more expensive than Threadripper motherboards. The regular Threadripper, not the Threadripper Pro, but like the regular Threadripper. ASRock had a board with no USB-As at Computex. Oh, that's going to be a long time. Because most people are still using, like, think about your keyboard, your mouse. Like, if you have a microphone, like an actual USB microphone, most of those microphones are still USB Type A, even though some of them might have USB-C on the connection to the actual microphone. So, I mean, there's just too many things that are still using USB Type A. Like the standard cable. The standard cable for a game controller is still USB-A. Even though, like, this end is USB-C, the end that goes into the computer is still USB-A. So, I don't see USB-A going away for a long time. Let's put it this way. SATA will go away before USB-A goes away. So, but this will be still a long time because there's still a use case for regular hard drives for storage. So I think SATA will still be around. I just think that it's going to become less and less relevant in the consumer market, and it will slowly become like a technology that is shoehorned into a specific use case like NAS storage, or like Threadripper would still use SATA ports because it has so many lanes. There's no reason not to give you SATA ports. So, but like the regular consumer stuff, like the gaming PCs and stuff, they don't actually need SATA anymore. Whether they like it or not. Whether they realize it or not, they don't actually need SATA. When you look at a new Steam game, and the game literally says in the recommended specs, recommended like X number of gigabytes of storage, and then it's like recommended SSD or SSD required or recommended, you know, like That right there is like, okay, what's the point of having SATA, right? Like, unless you're buying like a SATA SSD, and even then, SATA SSDs are terrible value because they're almost priced the same as NVMe, and they're like terribly slow compared to NVMe. So it's like not even worth buying a SATA SSD. But yeah, this is a cool motherboard for sure. This is definitely an interesting one. 2 SATA ports. Wow. It goes to show that you can do a lot of interesting things if you reduce your SATA ports, because you can reallocate that to other things. Right? Like that's how they're able to do dual NIC. They're able to do dual NIC because they don't have so many SATA ports, or they're able to give you that 5th M.2 even if it is kind of gimped. But they're assuming it's gimped. Like, I don't actually know that this is correct, but I'm assuming, like, this is how it would probably look for everything to work totally fine with no significant lane sharing. Let's see, what else do we want to talk about? We talked about the MSI. Oh, ASRock. Oh yeah, ASRock. Okay. So, light and bright. Okay, so someone was mentioning they want the Gigabyte X870 earlier because it's a white motherboard. I think ASRock's going to have some good ones that have a lot of RGB on them. So, looking at ASRock's lineup, it looks like the flagship is going to be the Taichi, and notice how they're advertising here Wi-Fi 7 and USB 4, like everybody else. So they have the Taichi, they have the Nova Wi-Fi. I don't even know why they mention Wi-Fi. Like, does this imply that there's going to be a Nova that does not have Wi-Fi? Then there's a Steel Legend Wi-Fi. The new Steel Legend looks really cool if you're going for like a white build. Whereas the previous Steel Legend had that military commando or that the camouflage gear looking design on it. And then Taichi Lite is probably gonna be the best value. Then you have the non-extreme. So you have the X870 Riptide, the X870 Pro RS, and the X870 Pro RS Wi-Fi, and the X870 Pro RS. They say godlike because it's supposed to be like the god tier motherboard. It's like the one motherboard that can do like everything. No compromise. Like, you want to overclock, you want external clock gen, you want unlimited VRM power. It has all that stuff. If you want the best DDR5 capability, it's got the 10-layer PCB. If you want like 7 M.2 drives, you have it right out of the box. You don't have to buy anything else besides just the M.2s. So it's basically, it has everything. Complete with a fan controller, an RGB fan controller. Let's see what else we got here. So, okay, so the Taichi, just like the previous Taichi, is an EATX. It's EATX 24 plus 2 plus 1. So, wait, that's one more power phase than the Godlike. Just when we thought that the Godlike had like the most god tier VRM, the ASRock casually just walks up with the Taichi and is like, we got 24 plus 2 plus 1. The Godlike, if I remember what those guys said in the video, they were saying the Godlike is a 24 plus 1 plus 1. This is a 24 plus 2 plus 1. So this one has one more power phase than the Godlike. And it's also an EATX, so it's the same physical size as the Godlike. They're both the really, really wide motherboards. They got the wide shoulders. You know, like the Godlike and the Tai Chi, anybody who played WoW back in the day, like, you guys know how in Endgame, it was all about how big your shoulder armor is. It was all about having, like, really, really big shoulders, like big shoulder armor. You basically wanted to look like a football player in the NFL. You know what I'm saying? So, and for those that are, like, outside the US, I'm talking about American football. So, you know, like, the really, really big chest armor. The Tai Chi and the Godlike are basically like football players. They got, like, the big armored shoulders. Like, they got the judgment set from, like, Tier 2 WoW Classic. You know what I'm saying? Meanwhile, like, Asus's Hero is, like, all scrawny and small. And Gigabyte's AORUS Master is, like, all scrawny and small. Whereas ASRock and MSI, they're coming in at the latter half, where, like, they're showing off their motherboards after the first two went and did theirs. It's like, hey, we got the big, big shoulders. You know, like 24 plus 2 plus 1. MSI's like, we got Godlike 24 plus 1 plus 1. ASRock's like, we got Tai Chi 24 plus 2 plus 1. So they one-upped the Godlike. 110 amp SPS for V-Core. That's insane. Like, this is so overkill. It's laughable in terms of, like, how overkill this is for the socket AM5. And then, okay, the whatever. Everyone's got 4 DIMM DDR5. 2 PCIe 5.0 X16. That obviously means there should be an asterisk there. I don't like when they just blanket statement, oh, we got 2 PCIe Gen 5 X16. What they really mean to say is they have 2 physically X16 5.0, but electrically it's either the GPU one is at X16 or both of them are running at X8, just like the Godlike. Then they got 1 blazing M.2 Gen 5 and then 3 Hyper M.2. Okay, so ASRock uses their own, they speak a specific language. When they say blazing means PCI Gen 5 SSDs. So they're talking about, like, something like a Crucial T700 or a T705. Like, we're talking like the fastest SSDs in the world. That is a blazing M.2. It's so fast, it's blazing. Then the second fastest stuff, like a Samsung 990 or whatever, those things are so slow in comparison. Those are called hyper. They're not blazing, they're hyper. So like a normie Samsung 990 Pro or whatever, those things are hyper. They're not blazing. So they got 3, they can support 3 of those. So total of 4 M.2 drives. So it would have been nice to see a 5th M.2, like on the Godlike, but I don't know if it's necessary, because what this probably means is that this probably has more SATA ports on it as a result. And for some people, they would prefer to have more SATA. So 2 USB 4, 1 USB 3.2 Gen 2x2, so that's like the, 20 gig USB front panel, 5 on the rear, type A, 7 total 5 gig USB A, and that's 3 on the rear and 4 on the front. 5 gig LAN and Wi-Fi 7, so it doesn't have dual NIC like the Godlike, it's a single LAN, it's 5 gig. And then the easy release, I'm guessing that means the button for the GPU disconnect. And then toolless M.2. Okay, everyone's doing the same thing. Everybody is going with no screws on the M.2 drives. Everything's easy to remove. Everyone's got GPU disconnect buttons now. So they all figured out the patent stuff. They all made their own whatever patent way of doing things because they couldn't copy Asus, and Gigabyte was like the second one. So it's nice to see everybody has the same stuff now. And then they have these other ones, which looks like it's the same thing, except it has less VRM, and probably less RGB. But everything else looks exactly the same. Yeah, the USB counts the same, the M.2. Oh, this one has... Wait, this has 5 M.2s. Wait, so the Nova has 5 M.2s and the Taichi has 4? Wouldn't that make the Nova more high-end? Oh, look, the Nova is doing what I assumed the Godlike is doing. They have an the 5th M.2 is a PCI Gen 3 X2, so it's half bandwidth, just like I showed in the block diagram. And it also supports SATA 3, so it's one of those weird ones that can do like legacy SATA M.2. So that's interesting. So the Nova actually is very much like the Godlike. That's one I have to keep my eye on, because this one, it doesn't have the insane VRM, but like 20 plus 2 plus 1, I mean, 110, that's still like totally sufficient for overclocking. Yeah, the Nova actually looks very impressive, guys. Like, I'm starting to think the Nova actually seems more impressive than the Taichi, just because it has that 5th M.2 drive. If you squint your eyes, the Nova looks just like the AORUS board. Wait, really? Huh, they don't actually have the website available. Like, you can't actually view the... It doesn't work. That's funny. The AORUS looks like this, though. And that one looks... it does look kind of like it. It actually makes me think of the AORUS Extreme. I think this one has more RGB, though, if this stuff lights up. Then they have the Steel Legend, which looks different from the old Steel Legend. But one thing that the Steel Legend does that I think has become a iconic look of the Steel Legend is they always have this RGB light strip down here that is underneath where the heatsink for the lower M.2 drives go. Alright, then we have the Taichi Lite, which is probably also going to be very good value. Yeah, I honestly, out of looking at these, you know what's weird? So is the Steel Legend not X870E? That's weird. So this is an X870. Why do they put this up here and the Taichi Lite is down here when the Taichi Lite is an X870E? And this is not even an X870E. I think that the Taichi Lite should be up here. Maybe because the Taichi Lite doesn't have RGB and the Steel Legend does. Yeah, this one does look good too, though. Like, this one literally... Wait, this has the exact same VRM as the Taichi normal. And it has the same blazing and hyper and the same USB count. Same exact Wi-Fi 7 and the 5. Basically, the Taichi Lite, if you don't care about RGB, you can probably save a lot of money. I'm talking like $100 or more just by getting the Taichi Lite. Like, that might actually be the smart buy. Unless you really, really want RGB or you're going for a specific look. Like, if you want a white build with RGB, it's probably going to be the Steel Legend. But the problem is the Steel Legend, this one doesn't have the E. Yeah, so that means that it's going to have only 3 M.2 drives. Basically, the way it looks to me is... So X870E is going to have 4 or 5 M.2 drives. X870 is going to have 3 M.2 drives. And in some cases, there'll probably be some higher-end X870s that also give you 4 M.2s, but the 4th one will take lanes from the graphics card. That's the only... Well, actually, yeah, well, yeah. If they're going to give you a 4th M.2 on a standard X870, they're going to have to take it from the GPU lanes. So, technically, if they wanted to take lanes from the GPU, they might as well just put like a 5th. They could even do a 5th drive, because they could take 4 for one M.2, 4 for another M.2, so the GPU would run at X8. And then you would still have the first one that doesn't take lanes. Then you'd have USB 4 for where the second one would normally go. And then you would have the chipset for the additional 2 or 3 drives. So yeah, you could do like up to 5 drives. Technically, you can do 5 drives on X870 Although the caveat is it takes lanes from the graphics card to get those 2 extra drives. Otherwise, you're doing like 3 drives. So, yeah, that's the name of the game. I feel like it's a balancing act with these PCIe lanes, and that's why some people refuse to buy like standard mainstream sockets, and they go for like Threadripper, because this is the exact reason why a decade ago people would never go with like an i7 4770K, for example, because they didn't want to deal with, oh, if I turn this thing on, I don't have this thing running, or it's like, oh, I can't use this slot because I'm using this drive, or I can't, or my GPU is only running at half bandwidth. You know, like, they didn't want to do any of that, so they just wanted full bandwidth. So they're like, no, I gotta go HEDT. So they would end up getting like a massive Intel 6-core Sandy Bridge E, or Ivy Bridge E as they called them back in the day. I can't help but think like X870E, X670E was basically AMD looking up to Intel's glory days, of the days when Intel had the Extreme platform, the E platform, Haswell E, Broadwell E, Skylake E. Intel used to have all the glory days, but then like that, all that stuff went away, and like, okay, Threadripper is like your only game in town now. I mean, you can go with like an insanely expensive Intel Xeon Sapphire Rapids, but it's like, why do that when you could go with a Threadripper Pro if you're going to spend that much money, right? Like, the core density and the value is going to be better on Threadripper anyway. So, yeah. I can't help but think, though, like, the E for extreme on these mainstream boards, like X870E, E meaning extreme, it makes me think of, like, Sandy Bridge E, Ivy Bridge E. You know, E for extreme, because that's what that actually meant. So it's like now AMD's got the extreme platform, whereas Intel used to have the extreme platform. That's why you want the Gigabyte AORUS Pro, the X870E. Oh, it's X870E. Yeah. Yeah. Yeah, that's the thing, because on X870, you don't have any of this. So if you have X870, you remove all this stuff in the middle. So you literally just have, like, you have this, and you have this. So you know what they have to do? They take, to make X870, because this is mandatory, this is a mandatory thing. This will go here. This automatically connects here. You see what I'm saying? So now you have one M.2. One M.2 Gen 5. Right there. And none of this in the middle exists. So delete all of this. This is all not here. On X870. So X870, what are you going to do? We need SATA. So what do? No 10 gig. No 10 gig. We need SATA. So you can still do 5 gig, but it's like, okay, we got to put like 2 SATA ports. So you got 2 SATA here. Because you got 4 lanes total. 1 for Wi-Fi 7, 1 for 5 gig, and the 1 for an SS, or 1 for SATA and 1 for the other SATA. So that's X870. And then what do you got over here? M.2 number 2, M.2 number 3, Gen 4. That's why it's 1, 2, 3 M.2s on most X870 motherboards. However, like I said earlier, you can still do 2 more on X870 if you cut the GPU lanes down to X8. So with, you know, like with X870, theoretically, it could handle 1, 2, 3, 4, 5 M.2 drives. So I wouldn't be surprised. Well, let's put it this way. I think the reason why we're not going to see a lot of X870 with 4 or 5 M.2s is because at the end of the day, I feel like they probably are just going to do this. They're probably just gonna go and build a motherboard with the dual chipset because they don't have to worry about, you know, like taking lanes from the GPU. I mean, they still can. Look at the Godlike. It does it with the expander card. So, but it's optional. They don't have to. But it's amazing, like, how much of a difference an extra 4 lanes of PCI 4 and 4 lanes of PCI 3 or SATA gets you in terms of the market segmentation with these motherboards. That's a good question, Jeb. So what I can tell you is Threadripper will probably get 9,000, but I don't know when it's coming out. What I can tell you is AMD is going to launch the Epic Turin later this year. And when I say later this year, I mean like in like 2 months. So like November. So keep in mind, Epic Turin, which is Zen 5 based server CPUs. This is coming in Q4 of 2024. So sometime after this, the Threadripper, in theory, Threadripper should also get a Zen 5 variant. But remember, this has priority because this is the big moneymaker for the high density, big socket, like server class hardware. So AMD is definitely going to dedicate most of their orders for like the big server socket to Turin, to Epic, essentially. And then all the leftover stuff later will go to Threadripper in lower volume. Because Threadripper is definitely a way more niche within a niche. I like to say Threadripper is a niche within a niche, almost within a niche. Because like if you want a relatively high-end desktop, you can get that with like, you know, a standard 9950X can handle pretty much anything like workstation oriented. But if you need the PCIe lanes, if you're going to do some specific use case where you actually need way more cores, like you actually need a lot of cores and you need a lot of memory channels and a lot of PCIe lanes, then Threadripper makes sense. But it's definitely a niche within a niche because Ryzen 9 can pretty much handle most high-end desktop tasks. And that's the reason why Threadripper went away for a number of years. Is because, you know, like the highest end 16 core got the job done for most people. But people kept demanding Threadripper come back, so AMD brought it back with Zen 4. And that's why we have Threadripper 7000 series. So, in theory, yeah, there should be a Ryzen or a Threadripper 9000 series. But don't expect that to come out this year. That'll probably be sometime next year. And it won't be like early next year. It would be like probably second half of next year. Or at the earliest, I would imagine like June or July for like Zen 5 Threadripper 9000. So, because it usually lags behind by quite a bit in terms of like when the Epic variant comes out. So, yeah. So if you're thinking of buying a Threadripper, if you're thinking of like building a Threadripper system, whether you're building one or you're thinking of getting one from like a pre-built, because you can get one from like Puget Systems and I know Lenovo has them, Dell has them, but I think Dell and Lenovo only have the super high-end like Threadripper Pro, which are very, very expensive. Yeah. So if it's not a priority, you can wait. But there should be a 9000 series Threadripper sometime next year. Yeah, because like, I mean, Threadripper 7960X. I mean, the R23 score for this is like 50K, you know, stock. This does 50K in R23 like stock versus the 99. So like Ryzen 9 9950X R23 score is around like 42K. So just keep that in mind. Like, what's amazing is Zen 5, actually, the multi-thread on Zen 5 is pretty good compared to Zen 4. Like, because Zen 4, like Ryzen... Trying to think, like, the Ryzen 9 750X R23 score is around like 36K. Just to put things into perspective, to give you an idea. This is a 24 core, 48 thread Zen 4 CPU. This is a 16 core, 32 thread Zen 5 CPU, and it's only like 4,000 points, or not 4,000, 8,000 points lower than the 24 core Threadripper from the previous architecture. So that gives you an idea. Like this kind of performance uplift, you can expect a similar uplift with the Threadripper 9000 series. What are my thoughts on Intel ditching hyperthreading for Arrow Lake? Yeah, so that is a good question, Hades. That's an excellent question. I think that'll probably be the last thing we talk about is going to be Intel. So Intel, my thoughts on Intel. Intel's trying to fight a war on multiple fronts right now. So I like to think of AMD as a company that has, it's like a war-torn country that has fought an opponent on the west side and the east side. So think of it like AMD is like this small country wedged between a giant blue empire to the west of it and a large green aggressive empire to the east of it. And it has constantly been having to fend off the blue team and the green team with its Ryzen stuff over here and its Radeon stuff over there. So that's AMD in a nutshell. It's a company that has fought a war on two fronts for time immemorial. And it wasn't always like that. It was kind of their fault when they declared war on the green team because they purchased they acquired a nation that was at war with the green team a long time ago, and that put them in direct conflict with the Green Empire. But so now they had to fight a war on two fronts. Otherwise, they were fighting against the big giant blue empire basically since inception. So then anyway, that's AMD. That's their history. Now Intel, historically, Intel has had like no major opponents throughout its history, with the one opponent being AMD, but AMD was always relatively small in size. So Intel, you can think of Intel as basically like the Galactic Empire in like Star Wars, and AMD is basically like the Rebels. It doesn't help that the Rebels wear orange, like the guys who fly the X-Wings, you know what I'm saying? Like they wear that orange getup. And that's kind of like the Ryzen CPUs are like orange. So it's like the Rebels are like AMD and the Galactic Empire is like Intel. That's kind of one way to look at it. So Intel's never really been opposed directly for a very long time until now. All of a sudden, okay, another way to put this from a historical context, Intel is like the Roman Empire. Think of the Roman Empire. Long ago. We all remember what it was like living in those days. So, you know, Intel, the Roman Empire, they were the dominant force. Like, they were the authority on technology. What they said goes. If they said you only need 4 cores, you don't need to think about more than 4 cores. stick to your work, stick to your labor. Don't question authorities. Don't question your reality. 4 cores every year. That's all you need. That's what we're going to give you. And you're going to give us your money. I mean, that's how it was. Oh, you want a new chipset? Too bad. Okay. We're going to give you a new socket anyway, whether you wanted one or not. Sorry. That's how it was in the days of the Roman Empire. So then what has happened recently is you have all these different tribal, barbarian-looking people. Like, for example, you have the Vandals and the Visigoths and the Ostrogoths. And you can think of them as the Vandals might be, oh, I don't know, let's call them AMD. And we've got the Visigoths and the Ostrogoths. Let's call that ARM and Qualcomm. Oh, and maybe there's going to be another group called the Vikings. And they're probably another team that has yet to release an ARM-based CPU until maybe sometime next year or whatever. And then, of course, Apple is also kind of there. So Apple is kind of like, I don't know, the ancient Greeks or something. They're like, they've always done their own thing. And it's like they were potentially conquered by the Romans. Kind of like how Intel came in and Apple was dependent on Intel for CPUs for so many years. But then Apple finally rose up and they made their M1 and their M2 and now they're M3 and they don't need Intel anymore. So like, bye, get out of here. We don't need you anymore. So Intel basically is now fighting like the Romans against the barbarians. You have Qualcomm coming in. You have ARM trying to bring in more different things. You have AMD continuously trying to invade Rome and take it over. And it's like, you know, this is all this stuff going on. So this is why you can see Intel from the outside. It looks like Intel's kind of struggling and falling apart. And they don't really have their act together. It's not consistent. If they split, if Intel splits, like the rumors are saying, if Intel splits, what does that sound like? Oh, I don't know. Maybe the Western Roman Empire and the Eastern Roman Empire. Can anybody say Rome and Constantinople? Like, maybe Constantinople is Intel Foundries and Rome is Intel, like chip design Intel. So, you know, these are kind of the things that are happening to Intel. So, very, very interesting time to live in and see, like, the once mighty Intel, like, slowly kind of declining in a weird way due to very, very steep competition from all these different players in the chip design space, and then other external market factors, like, for example, AI. And the whole, like, everyone's chasing AI, and Intel doesn't want to be left behind. So they're like, oh, we got to do our AI stuff too. We got to get into GPUs. You know, we have the best GPUs. Do we have the best GPUs? We think we have the best GPUs. Nobody needs anything better than an A770. Like, why does anybody need anything better than an A770? Like, it's totally sufficient. Like, like, you don't need a 1440p monitor. You don't even need a 4K monitor. Like, everyone should just be on 1080p 60 hertz. Like, that's what Intel thinks. Like, why do you need these higher end monitors? You don't need OLED. Like, a TN panel is good enough. The human eye can't see more than 60 frames per second anyway. You know, like, you don't need anything more than an A770. Don't think about Black Myth Wukong and the 18 million sales that it did and the 400% increase in Chinese people buying computer parts. Like, don't worry about that, you know? Like, why couldn't they have just bought the A770? They didn't need to buy anything else. It's like, it's kind of like that's the narrative internally, but in reality, that is like so far from the truth. Is Intel still competing with Threadripper? Yeah, they compete, but it's like such low volume. Like, you can't really find their stuff in the DIY market anymore. They do have something. They have Xeon, but Xeon, like you said, Xeon competes with Threadripper Pro, and no one really buys Xeon anymore unless they're buying a server. So it doesn't make any sense. So it's, yeah, I mean, it's there, but it's like no one really does anything with it. Elon buys Intel inside of 12 months. Second Roman Empire. Well, that's what I'm saying. Like, if they spin off the fab, right? Like, now it's like, oh, they literally just split the Roman Empire in half. But anyway, that is my take on Intel. Yeah. Oh, so that doesn't answer the original question, though. The original question was, why is Intel getting rid of hyper-threading? That is an excellent question. So there's a couple of reasons. One is they're just straight up trying to simplify the architecture and be more like Apple, because Apple doesn't have SMT or hyper-threading. And Apple has been able to show that you can get very good single thread performance without trying to like split the workload for a single core. So Intel's taking that approach, and they're basically not going to do hyper-threading anymore. And they actually have some impressive gains without hyper-threading. So I'm actually very impressed with Intel's multi-thread performance without hyper-threading, because one of the things that they said, or one of the things that it was speculated, was Intel's multi-threading would be worse than their previous generation because they don't have hyper-threading. It's like not even an option. You can't even turn it on. So the assumption was, oh, that means that like a 14900K would beat the new Intel CPU in multi-thread, but that doesn't really seem like that's true, based off of what I'm hearing. Sapphire rapidly disappeared. Intel's going fabless. No, I don't think they're going fabless. They don't want to go fabless. If they do, that's literally the Roman Empire analogy that I made. So I don't know if people were paying attention to that, if that made any sense using all those historical analogies, but that's kind of the way I see it. Let's put it this way. If Intel really goes fabless, they're going to have some serious problems. Yeah, Nero. Yeah, the Senate. Because I don't know what that's going to mean. Like, if they go fabless, what are they going to do? They're going to sell their fabs to, like, Samsung or something? Like, they're going to get sued, man. They're going to get sued by the US government if they do that. They just accepted like billions of dollars or something. Like, didn't they accept like billions of dollars from like Biden's CHIP Act thing to build fabs? Like, I'm pretty sure there was some kind of red tape in there that said something about like, you can't give this to some kind of foreign entities. You know what I'm saying? Like, because you know who one of the people, you know who's very eager to buy up Intel's fabs? SMIC. You guys know who SMIC is? Or SIMC? Is it SIMC? Who's SMIC? TSMC? SSMC? Who's the other one? No. What is the name of the... Is it SIMC? It's basically the Chinese TSMC. Like, Chinese... What's the Chinese TSMC? Chinese TSMC equivalent. Like, what is the name of that company? What is it? It's S something. Like Chinese Semiconductor Foundry. What is the name of that company? I can't remember it. I know it's like S something. Starts with an S. SMIC? Yeah, SMIC. Yeah, there it is. SMIC. Yeah, this is it. Okay, hold up. We got to go over to this. SMIC. Let's just go to the Wikipedia. Their website's not loading. Yeah. You know who's all too ready to buy up Intel's foundry? These guys. These guys. Semiconductor Manufacturing International Corporation. They are a partially state-owned, publicly listed Chinese pure play. So you think Intel can sell their foundries to this after they just got like $8 billion US from the US? Like they literally got $8 billion US tax dollars from, they got public money from Uncle Sam. And if they're thinking they can sell their fabs, you know who's ready to buy? You know who's got the cash ready? Because the Chinese government is gonna subsidize it on the back end. They are all too ready, man. Give me those Intel fabs. SMIC wants those fabs. Give them over, man. Hand them over. Hand them over. They're ready. We are ready. Like, no, it's not going to happen. Like, dude, like, it's like, no, man. The U.S. government's like, no. You're thinking of breaking yourself up? You're thinking of doing a Rome and Constantinople? I'm sorry, but you're going to have to stick together for a little while longer. So, probably the ones in Malaysia. Well, they have them in Germany. Intel's got fabs in Germany. I think they also have one in Israel, too. Or something. They've got something going in Israel. I know that. Intel's got a big presence in Israel. Senate will throw a fit. Yeah, man. I don't know. Because this is the primary buyer. Like, this is the one company that's going to buy them up. Like, for real. I'm not kidding. I'm not making this up. The Chinese state-owned fabrication. These guys are ready, man. Give me those fabs. That's hilarious. Like, if those rumors, like, I don't even know what Pat Gelsinger is gonna do, man. Like, the board's gonna kick him out if word gets out that they're thinking of like selling the fabs. He's out of there. Like, the board's gonna be like, nah, you're out. Sorry. I don't know what's gonna happen, though. Like, this is what I mean. I told you. Intel, and I literally made up this analogy comparing Intel to the Roman Empire, like, on the spot. I didn't even think of it this way until this live stream. I was just going along with it the whole time. But the fact that they're thinking of splitting, that's literally Constantinople and Rome. Like, what? What? Throw more money at the problem? Throw more. I don't think the government's going to be happy to throw more tax dollars. No. That's not. Well, okay. Intel is going to have to spend more money. They themselves are going to have to spend more money. If that's gonna happen, but like if they need to improve somehow, because like you guys gotta fix your problems. Like everybody has these problems. TSMC is also having problems. Like even TSMC is slowing down. Like this is a serious problem. Like a lot of people are saying like Zen 5 is underwhelming because this is what happens when you don't get a node shrink and all you do is a new architecture. Like. Meaning these sort of performance, like single digit % uplifts on like games and like lower double digit. So I'm talking like 15%, 13 to 15% uplift on multi-thread apps, performance uplift. That can become the norm because all these fabs can't get their act together and figure things out. So they have reached the limits of the silicon. I don't know. I mean, someone's going to have to figure something out because selling off your fabs is not the answer. Like that to me is like that's basically a signal that they're throwing in the towel. They're basically giving up. And these guys are ready. These guys are ready and waiting with bated breath. for Intel to hand the keys to that Lamborghini. Like, give me that Lamborghini. I'll buy that Lamborghini off you. That's basically what SMIC is like. Hey, Intel. Hey, Pat. Those Israeli buildings over there, like, can we have that? And then the ones in Malaysia, and give that to us. Like, we'll pay you. Like, we'll pay you some good money from like the Chinese government for that stuff. Even though they literally just took $8 billion from the U.S. government, what are they gonna do? Like, accept like $15 billion from the Chinese government? You think that's gonna fly in court with the U.S. government as the plaintiff? Like, I don't know. That's not gonna work, man. I'm telling you right now. That's hilarious. I didn't even think I would talk about SMIC on this stream. It wasn't even in the list. It just somehow came up. Oh, man. That's hilarious. But I think Nero's right. Like, I don't think they'll be allowed to do that. Maybe they could, like, close down a couple of fabs or something, and then, I don't know, but I think it would be really weird how they would go about selling, like, their older fabs, assuming they still have the older nodes up and running. I don't know what they're going to do. For some reason, though, like, I can't help but think that they have approached NVIDIA and AMD and have asked them, hey, do you guys want to build, do you want us, meaning do you want us at Intel Foundries to build your upcoming RDNA4 GPU? Like, they've probably asked AMD, like, hey, AMD, do you want us to build your upcoming RDNA5, like your secret weapon, like your actual architecture that has dedicated RT cores? Like, do you want us to build it? Like, we'll build it. Like, just give us some money, like, give us a couple $1 million, like several $1 million, and we'll build it for you. Like, I'm pretty sure Intel has gone to AMD and asked them, hey, do you want us to build your graphics cards? I mean, maybe. Well, I don't know about the CPUs, but it's like, they probably asked them, like, hey, you want us to, because, like, they're probably like, hey, everybody knows Intel CPU plus Radeon GPU is like, it's the most energy efficient setup in the world, right? Like, everybody knows that, right? Like, 14900KS, 300 watts. I mean, it's so nice in the wintertime. And you pair that up with a 7900 XTX Sapphire Nitro with the OC BIOS on. That's like 430 watts right there. 430 plus like 280 to 300 watt Core i9. Like, that is like, you don't need to run your heater in the winter. Like, everybody knows that, right? Like, Intel Core plus AMD Radeon, it's like the best combination. Like, everybody knows that. So they probably approached AMD and they're like, hey, you want us to build RDNA 5? But I don't know, man. AMD was probably like, okay, show us your node. And they're like, okay, this is it. And they're like, yeah, no, maybe next time, maybe, I don't know. Like, because, I mean, that's what this story was saying. Where was that one story? Like, this story right here. Intel's foundry business fails to impress. It's like, see, they're going around asking people, hey, this is our latest 18 angstrom. You want us to build RDNA 5? And AMD's like, after evaluating it, they're probably like, no, it's not good enough. Like, TSMC is still better. Try again, maybe next time. So then they go to Broadcom, like, hey, Broadcom, you want to use our 18 angstrom? And Broadcom's like, no thanks. So, dude, like, it's tough, man. This is tough. Like, the foundry business has proven that this is proof that the foundry business is very, very hard. Intel Israel has the development center for the processors and AI solutions software and cybersecurity development center, global development center, autonomous cars. Yeah, the heat coming off my 7800 XT made me get a new cooler for my CPU. Polar bears in Antarctica will start sweating if that scenario ends up happening. What? That's like the most random comment I've read all day. Polar bears. First of all, wait, hold on. First of all, are there even polar bears in Antarctica? I thought polar bears were like a northern hemisphere thing. I thought penguins were in Antarctica and polar bears were like up there in like the Arctic. Like in the tundra, like the Yukon in Canada or Alaska or Siberia in Russia. I didn't know there were polar bears in Antarctica. Are there polar bears in Antarctica? Everyone wants TSMC because they will actively help you optimize your designs. Doesn't Intel do that too? Oh, I forgot. Intel's never done that before. Because guess what? Intel's always made their own things. So yeah, maybe that's one of the things that they're not good at this point. Is it a good time to build a PC or wait? There isn't really any reason in waiting. I mean, honestly, from what we've seen about Intel's new CPUs, they're basically going to be like these. So it's like there's really nothing to wait for, to be honest. Like, because I think the leaks have shown the same exact Geekbench score for single thread as like Zen 5. And then but the multi-thread is very impressive though. Like, I don't know how Intel has done multi-thread unless those are fake benchmarks. Like, the fact that they're somehow outperforming the 14900K in the multi-thread is very impressive. Like, I'm surprised to see, unless those are fake benchmarks. So keep in mind, we have not seen any real benchmarks of the Intel CPUs yet. But from what has been shown, what has been leaked, the single thread is basically like Zen 5, and which currently has the fastest single thread, and then the multi-thread is actually a little bit faster, which is very impressive because they don't have hybrid threading. So I'm like, wait, how are they doing this? Unless this is fake, unless it's all fake. They're only in the Arctic. Alaska is in the Arctic. That's part of the Arctic Circle. The whole thing we were talking about was Antarctica. Antarctica is the southern hemisphere. Spam cores is what Intel is doing now. Bulldozer, pile driver, stressed. Well, no, okay, so honestly, guys, here's what I think is going to happen. I think, okay, when you compare Zen 5 to Zen 4, Zen 5 doesn't look like it's a worthy upgrade from Zen 4. But if you're on like an older CPU, like if you're on Zen 3 or if you're on like an older Intel CPU, then yeah, Zen 5 is an amazing upgrade. Because you're getting, like, if you're going from Zen 3 to, I mean, just to use my own numbers, like, let me just find my own numbers. Like, where's my, like, here's my, this is my review. Like, I did 2267 stock on a 9950X on an air cooler. Keep in mind, all these results that you see is on a Noctua NHD 15. So I don't know if everybody in the chat has seen my review. The review went live yesterday because I was delayed. I couldn't put it out last week because I was not available to make videos last week. So anyway, so the multi-thread score for a 9950X is like 42,000 versus like all the other 32-thread competitors, two of them being AMD's older CPUs, which are like way further behind. And Intel also, 13900K, 14900K, same thing, is basically 36,000. And this is with the patch. This is with the new BIOS update from Intel that will prevent the CPU from damaging itself. So that's what you get on the older CPUs. But see, like Zen 5 is doing quite a bit better. And the leaks for the leaks for Arrow Lake are basically showing the same exact numbers that I'm getting with Zen 5. So what is impressive about Intel's new CPU, assuming those leaks are actually true, because they could be complete BS fake news until we actually see reviews. But if those numbers are real, then somehow Intel has managed to find a way to get so much multi-thread performance out of a single thread that they're able to match AMD in multi-thread around, like, because the leaked benchmarks for Arrow Lake are showing like 42,000. Basically, they're showing like this sort of number on an Arrow Lake CPU. And that is a 24-core, 24-thread, whereas this is a 16-core, 32-thread. Now, keep in mind, the Intel CPU is 8 P-cores plus 16 E-cores, just like the 13900K, but yet without hyperthreading, it's able to get much better multi-thread, assuming that those leaked benchmarks are real. But in terms of the single thread, what's weird is the single thread on Intel's new CPU is basically the same as the Zen 5. I think I've seen it in the ballpark of 22-something to 23-something on R23. So it's basically very similar in single thread, which is really weird, because if the single thread on a 24 thread is able to give you the same multi-thread of a 32 thread, then how exactly does that add up? Like, the math doesn't seem to work. So either those benchmarks are completely fake, or somehow like the multi-thread is surprisingly good scaling compared to the single thread, because the single thread is not that much higher than these existing CPUs. So I don't know. But then when we look at the CPU Z, so the CPU Z leaks for Arrow Lake are also, like, they're basically the same as the 13900K, which is interesting. But the multi-thread is quite a bit higher. It's more closer to like what you would expect from a 32-thread part, even though it's only 24 threads. So I don't know. It's making me think that Intel's CPU is kind of looking like Apple's CPU in some ways. But that is interesting to see. But yeah, like we look at AVX2 for the Zen 5, and then AVX 512. It's like Intel's 13 and 14 don't even do AVX 512, so it doesn't even run. I don't know. I'm pretty sure Intel's upcoming CPU will still not have AVX 512 functionality. It's not really a super big deal unless software developers start using AVX 512 more and more, and then it could become a problem for Intel in terms of longevity, because the functionality is not in the CPU. So, and then Geekbench, like the other thing too is the Geekbench numbers on Intel's CPU look a lot like the 9950X. Like the single thread is in the same ballpark. It's like 34 something on the Intel CPU, on the new Intel CPU, and then the multi-thread is actually even better. So I don't know how they're doing like the multi-thread. Like either those benchmarks are completely fake, or somehow the multi-thread scales way better, even with less overall threads, which is very interesting if that's true. But yeah, that was very interesting to see. But when we look at, let me just go to the conclusion here. So yeah, in the conclusion, like these were the numbers that I got. So in gaming, 5% faster than Zen 4, 1% faster than Intel's Raptor Lake, 4% slower than X3D. And I think the 4% slower than X3D is kind of the disappointing thing for a lot of people. I think they were expecting it to basically win across the board, even against X3D. But other than that, like the average in like everything, like all the apps and stuff, it's like 13% faster than the Zen 4 that it's replacing, and it's 13% faster than 13900K and the 14900K, and then it's 15% faster than X3D, the equivalent X3D in terms of thread count in applications. So, and then it uses less power than the others. So that's basically what my results were. They will kill the rare Antarctica polar bear. Yeah, because if you melt the ice, the polar bear can't swim indefinitely. It'll get caught in the ACC. It'll get caught in the ACC. That's why. But yeah, I mean, that's... I'm trying to look. What was my... Where's my average game results? Because, like, CPU profile in 3D Mark. Right, like, these are the numbers. I forget what I saw for the Intel one on these. But, yeah, it shouldn't be too much longer to wait for those. But based off of what we've seen, the upcoming Intel CPU is basically going to be very much the same as Zen 5. So don't expect like an insane uplift over 13th and 14th gen. Meaning, if you're somebody on either a 13900K or a 14900K or a 7950X or a 7950X3D, you don't really need to upgrade to either Zen 5, which is basically what I say in the conclusion. Like, I mean, you know, like, especially the gaming stuff, like, why would you... It's like X3D was probably going to be the way to go for gaming. Doesn't matter. But for everything, like, you're only gaining, like, 13 to 15% if you're someone who's already on either Zen 4 or one of Intel's 13, 14. Basically, if you're on Raptor Lake or you're on Zen 4, you're pretty much going to skip Zen 5 and you're going to skip the new Intel CPUs because neither one of them is going to be any significant upgrade. So, yeah, I think the only one, I think HDZ said it best. Can't wait for Zen 5 X3D. I do think... So, Zen 5 X3D is probably going to be the most efficient and fastest option if you're looking for a gaming PC. Because I don't see any of the other things being a better option than that. But you're going to be waiting for the next couple of months at least, so... But yeah, that's pretty much it, guys, for this stream. I'm trying to think, like... Was there anything else that we were going to discuss? We talked about 5090. We talked about PS5 Pro. Oh, we didn't talk about RDNA4. I completely forgot about RDNA4. But we'll probably have to talk about it next time. Yeah, let me see. Do I have an article on that? I don't know if I even had... The only newest article was this one. So RX 8000, assuming that's what it's going to be called, RDNA4 GPU similar to Radeon RX 5000. This is something that we already kind of assumed for a while now, that the RDNA4 would kind of be like a reboot of the architecture, but it would not be the full package. Just like how RDNA1 was kind of like a reboot from GCN. So, yeah, that's pretty much it, though. Like, I didn't really have anything... I feel like we talked about this, like, on the Wukong stream. Because this was, what, 5 days ago? Yeah, I think we talked about this already. You hope for a Ryzen 9 9900 non-X with a cooler? You know, I don't know if they're going to do that. They might do that. I don't think they're going to do that on the on the single CCD options because the 9700X and the 9600X already run at 65 watts. So I guess the 9900X could run at 90 watts or 75 or something, and then you could use a Wraith Prism cooler with it. I don't know if they're going to do it, though, to be honest. Those would make really good CPU mining CPUs, though, if they come out with the... Because that's a really good way to get a CPU mining rig set up. You basically just use the Wraith Prism cooler that comes with it. But, yeah. I don't know. I think we were going to say something about RDNA4. I can't remember what it was. Oh, I think the rumor for RDNA4 is that it would get announced or shown off at CES, which is January of next year. So I don't think we're going to see... There's a slim chance that we'll see any new GPUs from AMD. I think there was a leak that said that the launch is going to happen this year, but I don't remember what that leak was talking about. I feel like if it does launch, it's still going to be at the very end of the year. Like, if it launches at all in 2024, it will be in December at the earliest. Keep that in mind. So here's what I think is going to happen. In November, we're going to get PS5 Pro, and we're probably also, sometime in Q4, we're going to get an RTX 5080 and maybe an RTX 5090. But I don't know when in Q4 that's going to happen. But I think we are going to see some NVIDIA GPUs, some really, really expensive NVIDIA GPUs at the tail end of this year, which means Q4, which means October, November, December. And then sometime in that window, NVIDIA is going to launch their new GPUs. And then AMD, like if they launch this RDNA 4 stuff, it would be like at the very end of the year, like December, or it won't be until next year. In the first part of next year. Yeah, 5090 is going to be like a really expensive GPU though. So I don't see it being that popular this time around. Unless they do the dual 12 volt high power, then all the people that have 4090s are going to switch over because they don't want to worry about... They just want the peace of mind that they won't melt their connector. So, otherwise, I think most people are going to stick with 4090. I don't really see much of a reason to go to the 5090 based off of what all the rumors have said. So, but the rumors are all over the place. Like, some people are claiming that 5090 is going to be so fast, like... It's going to basically be bottlenecked by basically everything at 1080p. Like, all the time. Like, you can't even... Unless you run, like, Black Myth Wukong or something with, like, the full RT turned on. Then... Or maybe Cyberpunk full path tracing. Then it's not bottlenecked by the CPU anymore. But, otherwise, people are saying, like, it's so fast. I don't know. Because I think NVIDIA's Blackwell... It's not gonna have the super big node shrink, kind of like AMD. Although I think it's gonna be a different node, but it's not the latest node or something like that. I forget exactly the story, but yeah, I don't think we're gonna see like an insane uplift. I think we're gonna see like 35% from 4090 to 5090, which basically means that the 5080 is going to be very popular because the 5080 is going to be let's see, if we go to this, yeah, it means that the 5080 is going to be like 15% faster than the RTX 4090 at like a much lower price of $1,200. So RTX 5080 will be $1,200, and it will be about 15% faster than an RTX 4090. I feel like that card is going to be the most popular Blackwell GPU of that generation. It's not going to be all about the 5090. Kind of like how, if you guys remember, with the 30 series, the 3080 was the popular card. Like, no one really cared about the 3090. Like, it was there, but no one cared. And then people who bought 3090 had issues where the VRAM on the back side cooked itself, so they had artifacting issues. They had to RMA it a lot. Or they started playing New World, and if they were using like an EVGA or something, it died because of New World killing the capacitors on the back of the GPU. So that's why 3090 was kind of like no one cared. But the 3080 was the one that everybody was like, everyone and their uncle and their sister and their brother's dog, like, all wanted 3080. I'll never forget it. I'll never forget attempting to buy a Founders Edition, because you guys know me. I only buy Founders Edition. It's Founders Edition or nothing. Like, if I'm going to go NVIDIA, it has to be Founders Edition. Otherwise, it's nothing. Like, it's either AMD this, AMD that, or NVIDIA Founders Edition. Otherwise, nothing. No NVIDIA. So it has to be Founders Edition. And I remember how terrible the experience was trying to buy the 3080 from Best Buy and NVIDIA.com, trying to buy this thing in 2020, and everyone and their brother's dog and their mom and their sister and their uncle all tried to buy 3080s at the same time, and the bots were ready and the scalpers were double ready, and it was like a no-win solution for everyone involved. For real. For real. Okay. The 5080 will be, well, the 5080 might be around 20%. Best case scenario, 5080 will be like 20% faster than the 4090. But most likely it'll be more like 15% faster than the 4090. No, the 5080 will be faster than the 4090. This is pretty much guaranteed. Jensen will not disappoint. NVIDIA will not disappoint. It'll be 15% faster than the 4090. They'll make it work. They'll make up some way. They'll invent some way to show that the 5080 is 15% to 20% faster than the 4090. I can see it now. He always does it. He always manages to do those things that he does. Everyone knows what I'm talking about. Like, he can make people feel like they have to spend money. Like, he has that ability somehow. Like, that's his special power. That's why he's the CEO. Like, that's one of the reasons why he's the CEO. So, 3080 was the one to get. I feel like the 5080 is going to be the one to get for the Blackwell series, not the 5090. The 5090 is going to be so stupidly expensive that no one and none of their relatives and no one's friends, none of your friends or your relatives are going to want 5090 because it's too much money, and it's not going to be able to justify the mediocre performance uplift over the 4090. And that is that. So it's going to be insane expensive, and it's not going to be that much faster. We're talking like 35% faster than the 4090. So it's like people are going to be like, oh, come on, man. What's going on? Everybody's doing the Zen 5. Everyone's got the low double-digit performance uplift of the Zen 5. This is like the harbinger showing the world what to expect with the upcoming hardware releases. So The thing is, guys, keep in mind, for anybody, I want to say this again because I want to emphasize this point, and then we're probably going to end the stream. For anybody who is on older hardware, the 5080 will be an insanely good upgrade. The same way a Zen 5 is a very good upgrade if you're on an older PC. Like if your PC is 3 years old, 5 years old, or anything older, this is a very nice upgrade. Likewise, if you're on an older GPU, for like a 20 series, 30 series, 50 series is going to be a very nice upgrade over whatever your 30 series thing is. So basically, anyone who's on 3080, guess what? Guess what? They're going to want 5080 because they're going to be like, hey, man, I'm going to go from my 3080 that I used for like 4 years or three to 4 years, and I'm going to go to a 5080, and I'm going to be faster than all those people who overpaid for the 4090. And they're going to be like laughing as they buy their 5080 and think that they're superior to the people who paid like $2,000 for an Asus Strix, which only has 2 fingers, for an RTX 4080 that looks like a cinder block with RGB vomit on it. And it's Captain America themed. Like, that's basically what they're going to be looking at. It's like, you know, the people, the 5080 buyers are the people who are like, they like to go to Starbucks and drink their latte, and they like to think how they saved so much money because they didn't buy a 4090, and they don't need a 4090 because it's a waste of money. And then it's like, oh, but as soon as the 5080 gets announced for like $1,200, and they see, oh, it's 15% faster than the 4090. It's like that meme of like that fox or whatever that like looks over slowly. You know what I'm saying? $5090 is only for creator. That's debatable. There'll be a lot of people that will be wanting to get that for gaming. They might make the 5090 and 5080 even bigger than a house brick. Well, 5090 is probably going to be really thick. 5080 is probably just going to be like a regular 3-slot. Honestly, I expect 5080 to basically look like this. 5080 is going to look kind of like this. Although NVIDIA does kind of need to redesign. I mean, NVIDIA only does like typically they'll do like 2 generations with the same cooler style, although that's not true for 20 series. So I don't know what they're going to do this time for the 50. Like, they might keep the same style from 40 series, but yeah, I don't know what they're going to do. The 5090 will sell because all the content creators that make money will buy it, just like they bought the 4090. The content creators are such a small group of people, though. Like, that's not representative of the overall market. The 5090 will sell, but I don't think it's going to be as popular as the 4090 was. You will buy a 5080 AORUS because you also want a white GPU. Assuming they'll have one. You're going to have a whole Space Odyssey. Oh, you're going to have a whole Space Odyssey in your case? Oh yeah, that's cool. That's funny. Yeah, I don't know what they're going to do for the redesign. Yeah, there's a lot of people that I know that have 3080, and they when they looked at the 40 series, they thought it was like a big waste of money. And they're kind of annoyed at NVIDIA because you can't do DLSS frame gen on 30 series. You have to be on 40 series to do that. So you'd be surprised. Like, a lot of people that I know that have NVIDIA GPUs, they actually use FSR frame gen to play. Well, if they even use frame gen. Most people don't actually use frame gen, but if they want to try it, they actually use the FSR frame gen on a 3080, which is hilarious. But you know, like, a lot of these people, they have 3080 and they're like 3080 because you guys may have I made a video right earlier this year. I did I did 4080 Super versus 3080 Ti. And the vast majority of the comments on my video, on my comparison, was, thanks for saving me money. I was thinking of getting 4080S, but I decided not to based off of your video. Like, a lot of people looked at my video and they were like, yeah, the 4080 and the 4080 Super is a huge waste of money for somebody who has a 3080 GPU. Or even though that video was about 3080 Ti, like, most people had a 3080 and they watched the video and they're like, yeah, no, this is like not worth, this is not worth it at all. Because the thing is, 4080 is what? Well, the sad thing is, like, technically, this is like 50% faster. According to Tech Power Up, 4080 is like 50% faster than a 3080. So, okay, if we use 3080 Ti, because my video was actually 3080 Ti versus 4080S. 4080S is 35% faster. So, meaning the uplift from 4090 to 5090 will be kind of like what I showed in my comparison video of 3080 Ti versus 4080 Super. Also known as 4080 Ti. So the thing is, like, that I've already kind of shown what the performance uplift is going to look like for a 4090 versus a 5090 without even having the 5090. You know what I'm saying? Like, because I'm showing 35% uplift in a video, and people who have 3080 are looking at that and they're like, yeah, that's not worth it. But then I'm thinking, like, okay, I guess they don't need to upgrade. But the reality is, they have a 3080. I didn't show 3080 versus 4080. So my difference was 35%. But the reality is, if someone has a 3080, like, that's like a 45 to 50% uplift. So that is actually a significant uplift. That is a true generational uplift from 30 series to 40 series. But people, for some reason, walked away from that video thinking, like, yeah, that's not good enough for some weird reason, which I thought was kind of interesting, which almost plays into the narrative that most people skip the next generation. Meaning, if you're on 20 series, you skipped 30 series, and you probably went to 40 series. And if you're on 30 series, you're skipping the 40 series, and you're probably going to go to the 50 series. There was a lot of comments on my video which had that mentality, that gave off that vibe, like, oh, these people are going to completely skip 40 series, and they're just going to go to 50 series. For me, you might just hold until you see 100% plus, like what happened when... Yeah, that's if you wait. Like, if you wait the 5-year plus, then yeah, you'll see those sort of uplifts. 4080 is 15% faster than 3090, so I think you are correct about the 5080. Yeah. Yeah. Yeah, that's pretty much... it's pretty accurate, guys. Like, guys, NVIDIA... What I'm saying is NVIDIA is very predictable in terms of their performance uplifts. So you can predict with high accuracy, like, where the next generation will fall without even, like, seeing anything, without even looking at any leaked info. So you just look at historicals. And you know why you can use historical data to make an educated guess? Because put yourself in the position of the engineering design team that has to make the 50 series GPU. Like, are you truly going to be able to make something that's like 100% better? No, you're not. That's not how the world works. That's not how generational uplifts work. Unless some radically magical thing happens with TSMC and process technology, there's no way that's feasible. So you're going to have very, very, like, not easy, but you're going to have very clear goals in terms of what you're designing, in terms of your performance target uplift, all that kind of stuff on target for certain features and all that stuff in the roadmap. That is how engineers will design the next generation hardware. They're not going to just arbitrarily, magically make it 60%, 90%. That's not how it works. So it's like I don't need to watch a leaked video to understand like what I'm going to expect from the next generation. All I got to do is look at like, oh, what was the uplift from 30 to 40? What was the uplift from 20 to 30? What was the uplift from 10 to 20? You know, I just got to look at the historicals. And then also you take into account, like, when you compare those previous generations, you look, okay, what was the node? Was there a big node shrink? Was there not a big node shrink? Was there a vendor change? Like that, like were we on Samsung or were we on TSMC? Like that was the kind of thing that you look at to try to make these educated guesses. So yeah, it will be about, the 5080 will be about 15% faster than the 4090 because NVIDIA, like the worst case, NVIDIA has to settle for that kind of uplift. Like that's how they'll do it. And they'll make it happen through whatever means necessary, whether it means obfuscating the results by using software, like some new kind of frame generation or some new kind of technology, like with ray tracing, that makes it create a 15% performance delta between the old generation and the new generation. So NVIDIA can play those games. They do this stuff all the time. They will never make their newer card look worse or equal to their older card. And when I'm referring to like their second fastest card to their previous fastest card. So I'm talking about 5080 versus 4090. I'm not talking about 5090 versus 4090. I'm talking about 5080 versus 4090. 5080 will be faster than the 4090. NVIDIA will make it happen. They never disappoint. They always make it happen. Their shareholders expect them to do this. And if they can't get that uplift naturally, they will have to stoop to some kind of silly obfuscation with the results, like they did with the 20 series. Like they'll do that kind of stuff to get the uplift that they need to show to the public. Rest assured, it will happen. So NVIDIA will try to show, but Gamers Nexus won't use it. It doesn't matter what Gamers Nexus says. NVIDIA is going to say that, and then the public at large is going to run with that narrative. And all the OEMs are going to be on board with that. All the pre-builts are going to have that narrative, and they're all going to use it in their marketing. And let's not even talk about like the global market. So yeah, no, like that's how it's gonna go. Like NVIDIA has this sort of power. What NVIDIA says doesn't mean it's true. But yeah, I know, but that doesn't matter. Like NVIDIA will show what the results are, and all the people who will look at the results will be like, they'll just start parroting the information all over the internet, all over Reddit and Discord, and then everyone will just confuse each other. I mean, we know how this goes, guys. Like, come on. Like, and then when the reviewers will show how it really is, people will be like, okay, yeah, NVIDIA's just stupid like they always are. But the thing is, what will end up happening? What will end up happening? People will still end up buying the 5080 over like a 4090. They'll still do it. You know why? When all the tech reviewers said the 4060 was trash and the 4070 was trash compared to the previous generation because they weren't that big an uplift, what did people do? What did people actually buy? They still went and bought 4070 and 4060. Like they still did it. That's what I'm saying. Like it doesn't actually matter what the reviewers say, because the blind will follow the blind, so to speak, and they'll still go and get the thing that the reviewers said not to buy. Like, you know what I'm saying? Like, people are not gonna... I mean, I've had this conversation with people. I've seen people in Micro Center that were looking at buying a 3060, and they ended up buying a 4060, Even though, like, everyone was saying, there's no, like, what's the point? Just get the 3060, save some money. And they still ended up buying the 4060. So, because NVIDIA told them it was better. Like, come on, really? Like, the 5080 will not have a node advantage. It doesn't need a node advantage. That you keep putting too much emphasis on the node advantage. Look at Maxwell and look at Kepler. Look at Maxwell and Kepler. Look at what NVIDIA did with Maxwell. What do they do with Maxwell? Delta color compression. You didn't have delta color compression on Kepler. Also, what do they do? Tile-based rendering. You didn't have tile-based rendering on Kepler. So, meaning they did things with software innovation to make up for the lack of the performance uplift that you would regularly get. So they could create the advantage through other means. So it doesn't always have to be the node. Remember, guys, NVIDIA is a software company first and a hardware company second. So if they can't get the expected performance uplift out of the hardware naturally, they will rely on their magical powers with software to make the solution better in a way that they need it to be. So this is how we're going to see it. And when I can see it now, when we're comparing the 4090 with the 5090, all the narratives, all the comparisons will be done at 4K resolution. I can see it now. All the data that NVIDIA is going to show comparing 5090 with 4090 is going to be 4K results. They're only going to show 4K because they know that 4K is what will show the biggest delta from Blackwell and Ada when comparing the two 90 class cards. So that's how they're going to do it. Watch and learn. If you don't believe me, you'll see what happens. So anyway, I think that was it. We were supposed to talk about RDNA4, but there was like nothing else to say about RDNA4 at this point. Understood, you're going to buy the 5060 Ti. Yeah. So anyway, guys, that's going to be it for this stream. We talked a lot about GPUs, which I was not expecting to do at that last part. But yeah, the NVIDIA stuff should start showing up soon. Like, I would say, like, next month. There's going to be an announcement at some point. And then it will probably launch one of those GPUs in Q4. I'm guessing the 5080 is going to be first. So, we'll see. Anyway, guys, that's going to be it for this stream. I have to do a bunch of stuff, and then I gotta like go to sleep, so I won't be able to join the Discord. I wasn't expecting the stream to go on this long, but I think this was a good discussion. Anyway, that's gonna be it for this week. I don't know if I'm gonna be streaming. I still need to finish Black Myth Wukong. I'm still like on chapter 3. I haven't had a chance to play the game this week at all. Since the last time you guys saw me playing that game on stream. So I am trying to finish that game, and then I am going to be covering Space Marines. So Warhammer 40k Space Marine 2 is the next game that you can expect to see me streaming on the weekend. So that'll probably be like not this coming weekend, but the weekend after. So that's going to be it, guys. Yeah, Space Marines 2 is very, very good. But I unfortunately won't be able to play it until like next week. So, anyway, guys, take care, and I'll catch you next time. Thanks.